At the registration desk, you were given a name tag and you have been assigned the table number. We kindly ask you to please take your seats. If not, Marcel has been authorized to release her guard dogs, and please keep in mind they have also been trained to snap at ringing mobile phones, so please, I strongly encourage you to put them on silent or do not disturb mode. The Chamber would like to start off by thanking its sponsors who are supporting the conference in our gold tier, the Ministry for Transport, Infrastructure and Public Works, Baxter Limited, Schneider Electric, in our silver tier, Teva, Foundation for Medical Services, Speculo, Tectraco, Connect, ST Microelectronics, and in the bronze tier, Aerobindo, Biosynth Engineering, Care Malta, and St. James Hospitals. For additional details about our speakers today, we recommend accessing their biographies via the comprehensive e-booklet. You can easily do so by scanning the QR code provided in your table or on the name tags distributed during registration. This is a measure is of course in line with the Chamber of Engineers' commitment towards sustainability, including the reduction of paper usage. To start off the conference, I would like to welcome on stage the President of the Chamber of Engineers, Engineer Malcolm Zammit.
Good morning to all. Thank you, Nikki. Honorable Minister, Dr. Bonnet, Honorable Dr. Giglio, Honorable Members of Parliament, esteemed colleagues and participants of the 31st Annual Engineering Conference. Once more, we have come together at the Excelsior for a conference about the subject of engineering in healthcare. I'm saying this because the last time that the Chamber opted for a conference on this subject, it was precisely hosted here in this hotel. This was back in 2013, and the conference was then called Engineering the Backbone of Healthcare, for whom may recall. A decade has passed since then, and much has changed, surely in the development of these intersecting fields of engineering and healthcare, and also within the engineering profession in the local context in Malta. While it is true that we find ourselves here in the same venue, this time we are enjoying a much larger and diverse audience. Larger because of an increased interest in areas of development for both engineers and the profession as a whole. And diverse because of a greater recognition that we need to work together to be truly successful in our endeavors and our projects. In this hall today, the majority of us are engineers, as you can expect, coming from different backgrounds, but we are also accompanied by a good number of healthcare professionals. These are coming from medicine and surgery, pharmacy, nursing, radiography, podiatry, speech therapy, and other fields. With such a diverse participation, we are setting the stage to what is to come in the conference program of today, which we have carefully developed to portray the sheer potential that cross-functional collaboration between engineers and healthcare professionals can have on the future of healthcare. I think we can all agree that the application of engineering in healthcare has garnered increased recognition and popularity over the past years. Therefore, we were very hopeful of a positive reception for this conference once we had actually decided to go ahead with this theme. I can assure you that the program design was not without its own sets of problems and challenges. But I'd rather call these positive problems because we found so much content and expertise in the local sector that it gave us some quite challenging decisions to take in order to conclude the final lineup that we have today. If we start by looking at the field of engineering research, we immediately realized the level and breadth of activity which is ongoing, with various projects in biomedical engineering, biodesign, cybernetics, biomaterials, digital health, and many other fields and subjects. I am really looking forward to hear about a sample of these projects in the first session concerning research and innovation. In the second part, we want to get you closer to medical facilities and how engineering and technology are transforming the provision of care. What is the engineer's role in hospital? How is digitalization influencing healthcare? How do patients benefit from engineering? These are all questions which our speakers will be attempting to answer. Then, for our third and final part of this conference, we have dedicated a section for the underappreciated, I would say, sector of manufacturing, specifically with respect to medical devices and pharmaceuticals in Malta. This section is expected to address the challenges of this sector as well as future opportunities, focusing on the fundamental role that engineers will play in the future growth of this sector. As engineers, we are known as agents of change, and we have the ability to bring about a general improvement in the healthcare sector. Following today's program, I'm anticipating a much better understanding of the joint potential of professionals who collaborate together. Together, we can be the drivers of innovation in the healthcare sector and others. One thing that I usually do during the start of such an address is that I salute my colleagues in the Chamber's Executive Council, without whom I certainly cannot be here in this role. But today's conference is perhaps a little different for me. As besides being joined by most of the Chamber's Council, I am honored with the presence of many of my day-to-day work colleagues, with whom I carry out rewarding work for our patients worldwide. Such an occasion increases my motivation to work harder for the engineering profession. So on a closing note, I would like to express my thanks to the Chamber colleagues who have organized this conference, to all the event sponsors who make the conference possible, to the Chamber's corporate sponsors, partners and corporate members, and to all the speakers and discussion panel participants. I look forward to meeting you later on, and I trust that you will find this conference very fruitful. Thank you.
Thank you, Engineer Zammit. I would now like to welcome on stage the Honorable Dr. Chris Bonnet, Minister for Transport, Infrastructure and Public Works, to deliver his address.
Good morning. Naħseb id-doktor intqalet biex juri l-kulħadd li minix engineer. Bonġu. Good morning, everyone here today, colleagues, esteemed guests, and more importantly, you, the engineers, who are maybe the most profession where you actually listen and learn from one another. As someone who loves and comes from the world of sport, my preferred way to associate and understand the role of an engineer is through that amazing sport which is called Formula One. The switches, the aerodynamics, the speed of the car, these are all the fruit of hours and hours of work by engineers who try to be innovative with the technology at hand and push the limits of what is possible to do with the car. And also hoping that Adrian Newey joins Ferrari next year. And in the same way, in other spheres, engineers are always pushing the boundaries of what we can do today and what we will do tomorrow. The improvements in technology that you bring help society do more and do it better. And more than ever before, society today is reliant on the technology that you develop. And this statement will be even more true in the future. We are more technological, more interconnected, and more reliant on the ingenuity and the geniality of engineers. Indeed, as you discussed last year, engineering is the key to the future, and this is very much the case in the healthcare sector, where technological evolution has been nothing short of revolutionary. From telemedicine to wearable devices that monitor and manage patient health in real time, we are witnessing a radical shift in how healthcare services are delivered. Artificial intelligence now predicts patient outcomes, customizes treatments, and revolutionizes diagnostic accuracy. I'm not speaking just about the distant technologies of tomorrow. I am referring to advances we are living, improving lives at this very moment. Just last month, I was reading about how more operations are now being done using robotics. Some operations being done by doctors not even in the same hospital. Without engineers and engineering, this would not have been possible. And that's why engineers are at the heart of this transformation in society. It is people like you who imagine, who design, that we have these technologies. You improve efficiency and reduce costs. You create systems that help address critical doctor shortages and allow for a focus on prevention rather than just treatment. Your work ensures that technology not only supports but also advances the healthcare profession. Yet, as the world advances, we must also secure and make sure that we stay up to speed with everybody else. Malta is not there just to participate in the medical technology revolution, but also to try and take a leading role in it. This vision is supported by continuous investment in healthcare, more specifically, the technological infrastructure around it through which we can serve our patients with the best that innovation has to offer. The government looks at the medtech sector as one of the economic niches that is budding, and we want to continue supporting the industry as it promises high-quality careers and better patient care all in one. Healthcare is not a privilege, but it is, in my opinion, a fundamental right. This is why we believe that we must offer the best that we can to our citizens. So much so in Malta, according to Eurostat, we boast the third highest life expectancy in the EU. And to remain amongst the best, we must prepare for the technological transformation. But how do we prepare for this? We require more than just infrastructure and money. We need engineers who are not only skilled in technology, but are visionaries, capable of steering us towards that vision. Similarly, our healthcare professionals must be more than just medically proficient doctors. They must be adaptable, capable of integrating new technologies into their practices and work with engineers that develop these tools. This relationship between engineering and healthcare cannot happen in silos. It requires a structured dialogue and collaboration across disciplines. We need to explore how we can develop partnerships within the industries and between the public and private sectors that look into developing this bond that needs to be created. It is in that way that together we can foster an environment where innovation flourishes and where our healthcare system can transform to meet the needs of every Maltese and Gozitan citizen. And on this matter, there is much that we still have to do. Personally, I think this is where we need to work more. I believe that by building such a culture and framework would be laying a stronger foundation for the medtech industry and make Malta not just a follower, but possibly a leader. Therefore, in view of all this, I would like to extend my deepest gratitude to the Chamber of Engineers for organizing this conference. I would like to applaud the person or persons who came up with the team itself today. I think it is very well suited for where the country is headed, and hopefully you can share ideas, we can share ideas that will one day come to fruition. Because in the end, this will improve the lives of people out there. Because at the end of the day, this is what you are here for as engineers, and this is what me and my colleagues sitting here are there for as politicians. I would like to thank you and wish you a great conference today. Thank you very much.
Thank you, Minister. I would now like to call Opposition Spokesman for Infrastructure, Manufacturing and Capital Projects, the Honourable Dr. Joe Giglio.
Good morning, everyone. Thank you very much for this invitation. I am addressing you today as PN spokesperson for infrastructure, manufacturing, and capital projects. I have this new role which has been given to me, but I must take the opportunity to thank 4 colleagues who are parliamentarians with me, who are all engineers. In fact, the Nationalist Party is very well represented by engineers in Parliament: Ryan, Mark Anthony, Stanley, and Rebecca, who is not with us. Thank you very much for your assistance. Now, of course, the theme that we chose today is to delve into the realm where engineering prowess meets human welfare. We are delving into the realm of healthcare and how engineering can effectively sustain tomorrow's healthcare. This is a very important topic, and this is a very relevant topic, because it is a domain where innovation, which you bring about, saves lives. It is a topic where your ideas bring about a better quality of life. To this, we can only thank you. But in the fast evolving landscape of healthcare, unfortunately, and this is not good, engineers are the unsung heroes whose contributions are often overshadowed by the medical professional. Yet we must keep in mind, and you must be proud of the fact, that it is you engineers who build the platforms, the designs, the devices, who develop the systems and do all the maintenance needed to medical equipment, all so vital in modern healthcare. And therefore, it is also the duty of the state to project this idea that in healthcare, engineers are not unsung heroes. Consider for a moment the marvels of medical imaging, from MRI machines to CT scanners. These transformative technologies owe their existence to your ingenuity. You conceptualized them, you refined them, and you implemented them. Engineering robotics is now even making it possible to maximize a surgeon's time. These engineering advancements are making it possible for surgeons to be virtually present for medical interventions. Undoubtedly, this is improving our healthcare. And it is also improving how we can sustain tomorrow's healthcare. In this age of digitalization, artificial intelligence, you as engineers are at the forefront of revolutionizing healthcare through telemedicine, to wearable devices, to health informatics, but most importantly, by your own perseverance and dedication. You can help to craft an interconnected ecosystem that empowers patients, that streamlines workflows. And you can help to facilitate remote monitoring, thus extending the reach of healthcare to the farthest corners of our society. Robotic surgery, 3D printing of organs and tissue, diagnostics are reshaping the healthcare landscape, offering new hope to patients and practitioners alike. And to this, we can only thank your profession. These breakthroughs are not, therefore, merely products of scientific inquiry, but the fruits, yes, of interdisciplinary collaboration, where engineers synergize with medical professions to bridge the gap between theory and practice. However, amidst the boundless opportunities that engineering offers in healthcare and beyond, we are confronted here in Malta with a concerning trend. And this is the dwindling interest of young minds in pursuing engineering as a career path. In my first meeting with the Chamber, one of you commented that it is not cool to be an engineer. This is a perception which we have to break and which we need to address. In an era dominated by what people consider as glamorous professions and fleeting trends, I believe that we have a duty as a state to ensure that engineering is not overlooked. You are the architects of progress, the innovators of dreams that can turn into reality. And therefore, this issue of dwindling numbers of persons who choose a career path is something which we need to address and which have a duty to address in order even to have a sustainable healthcare. But to address this issue, we must redouble our efforts to inspire and educate the new generation about the vast potential of engineering, and that, yes, being an engineer is also cool. We must showcase the challenges and the tangible rewards that await those who dare to venture into this dynamic and beautiful field. We need to foster, as a state, a culture of innovation and excellence, of innovation and entrepreneurship. In that way, we can nurture a new breed of engineers who will lead us into a future which will be brimming with possibilities and which will therefore work hand in hand with the theme of today's conference, sustaining our healthcare tomorrow. Therefore, in conclusion, let us, as politicians, reaffirm our commitment to harnessing the power of engineering to sustain and indeed enhance tomorrow's healthcare. Let us also use this conference to celebrate your ingenuity and therefore inspire future generations to join you in this noble endeavor. I believe that together, focused on where we wish to arrive, we can definitely achieve this aim. And on that point, whilst I thank you for your attention, I close here my intervention and wish you a great conference. Good day.
Thank you, Honorable Joe Giglio, for your intervention. Like you, we're very happy to see more engineers in Parliament as well. This was the work of an architect. Allow me to give you an overview of the conference today. The conference will be split in 3 sessions. Session 1 is at the core of the conference and will focus on engineering innovation in healthcare, the research aspect. It will be followed by a 30-minute coffee break and will eventually conclude with a panel discussing the impact of innovation on the future of healthcare. The second session, which focuses on the theme of technology and medical facilities, will immediately follow, eventually concluding to a 1-hour networking lunch. Finally, session 3, titled From Production to Patient, Healthcare Manufacturing, will eventually lead us to the closure of this conference. Of course, don't take my word, you can follow the booklet program which has been provided to you. It will be a very intense session, so therefore, given our time constraints, I kindly ask you to hold on to the questions until the appropriate period following each session panel discussion. Allow me, therefore, to open up session 1, and please allow me to welcome our first keynote speaker, Dr. Engineer Carla Zoppardi, Managing Director of Biosynth Engineering Limited, who will introduce us to the life-saving combination that is engineering and healthcare.
Thank you very much. Good morning, everyone. Honorable Minister, members of Parliament, distinguished guests, and colleagues. I was asked by Malcolm to provide a speech to set somehow the tone for the conference. And I'm happy to do this because I consider myself lucky to be an engineer who has essentially been able to touch various phases of biomedical engineering throughout my career. So hopefully I will be able to provide a glimpse into the many different forms that biomedical engineering can take. So I'll start with a bit of a personal story. My father is a family doctor. He still practices until this day, although he is in his 70s. Whereas my brother, on the other hand, is a very gifted engineer with an eye for detail and a knack for all things technical. Growing up, these two men were my role models, both deeply passionate about their vocations, and obviously I would at times tell people that I wanted to become a doctor like my father, and at times say I wanted to become an engineer. You know, the decision was not an easy one. It had me scratching my head well into my late teens until I finally stumbled across the solution, which would be biomedical engineering. And this happened, thankfully, just before I took up the engineering degree at university. The field was vast, as I would soon learn, from carrying out research and development on new medical devices or developing software, or else working closer to patient care in a hospital, or perhaps even helping to design a hospital. Which field would I end up pursuing? Over the past 15 years, I can thankfully look back and say that I've had the good fortune of dabbling my fingers in all these areas. And in this presentation, I want to spend just 5 minutes on 3 different fields of biomedical engineering that I've been lucky to work in, to show you the many different dimensions that this profession can take. My first experience came upon graduating in electrical engineering at University of Malta. There weren't many options back then, so I figured, what would be a place that's definitely going to have a lot of medical devices? A hospital, of course. I decided to knock at the door of St. James Hospital, asking them if they did have a medical engineering department. And their initial reply was the all too familiar, "Thank you, we'll keep your CV in hand for future vacancies." But I wasn't going to give up. I pestered the director several times, basically offered to work for free, anything to get my foot through the door. Thankfully, they were merciful and they offered me a job. And this brings me to the first and longest stretch of my career, which is biomedical engineering in a hospital setting, more appropriately referred to as clinical engineering. One's role as a clinical engineer is itself quite diverse, but the main focus is around the life cycle of a medical device. So, starting from the procurement process, my role and that of my colleagues within the department was to initially sit down with clinicians to understand their clinical needs and to carry out market research to find suitable medical devices which would fit their bill, but which also fits within the management's budgets. Our job was therefore to specify and determine what was required, draw up specifications, and assist in the procurement process. After overseeing the procurement aspect, we would then oversee the installation and commissioning of such equipment. Medical equipment is normally designed to meet strict performance criteria, and therefore during the installation and commissioning, together with our suppliers, we would go through acceptance testing procedures to validate and ascertain that the equipment is functioning as specified. Next, we'd involve ourselves in training the clinicians on the correct use of the equipment. A fine balance is at play here because, on the one hand, the engineer's background and knowledge in the subject allows him to show the end user on how the device works, what features are available, and how they are used. But on the other hand, as engineers, unfortunately, we do not actually get to use these devices on patients. So there's something missing here from our part. This certain aspect of training, the actual usage techniques on patients, is something that we do not impart ourselves to the clinicians, but it is something that they bring with them from their own training. That being said, looking back, there were many occasions where sharing insights together with the clinicians and sharing, crossing the bridge between the technical and the clinical aspects offered opportunities where our background could help influence and improve the clinician's technique. With the devices rolled out for use, our role was to then constantly monitor the performance of the devices in the field. On a regular basis, typically annually at least, unless the manufacturer has recommended otherwise, the devices will be pulled out of service to go through performance verifications to ensure they're working correctly. Using calibration instruments or patient simulators, the devices are tested as if they are connected to a live patient, and their performance is checked to make sure that they are functioning properly. In parallel, if a device malfunctions, corrective action would be implemented, whereby the device would be taken out of service and sent in for repairs. These will either happen in-house, whereby my colleagues and myself would source any necessary spare parts and carry out the repair ourselves, or else we would outsource the repair to local agents and their mother companies if the faults presented themselves to be more involved. In any case, the ultimate metric was device uptime, because this ensures continuity of service for the hospital. Aside from these technical aspects, the clinical engineering department would also involve itself in a certain amount of administration work as well. So inventory keeping of medical devices and of spare parts and consumables, regular upkeep of insurance records, purchase values, monitoring the cost of upkeep of a device to determine when it is time to decommission it. All this is part and parcel, all this administration is part and parcel of every vocation. In 2014, a decision was taken to commercialize this department and spin it off into a separate business entity, which is today Biosynth Engineering. Biosynth is a medical engineering firm focusing very heavily on medical and laboratory equipment and instrumentation. We supply and distribute equipment from suppliers that we collaborate with in both the human and the veterinary life science markets. Given our roots in biomedical engineering, we put great emphasis on technical service, validation and repairs. Now, outside the regular life cycle of medical devices, working at St. James also brought with it the possibility of working on large capital projects. Throughout my 15 years of working in this field, I've had the opportunity to be involved in the design of new local and international hospitals for the group, designing and constructing additional surgical theaters, as well as revamping entire medical floors. These capital projects bring in with them a multitude of engineering skills, because apart from what we mentioned earlier, and what goes into the research of what medical equipment is needed for a facility, a lot of research goes into what building services might be required for large capital equipment, such as sterilizers, MRIs, CTs. So this entails carrying out a lot of work to design the building services that go along with such equipment. This brings me to another chapter in my career, or another phase of medical engineering, if you will, and that is hospital design. Back in 2012, St. James were in the process of constructing a hospital in Libya. I was very lucky to be involved and to be part of the design team. And for this project, St. James had partnered up with a large turnkey supply company, which would eventually supply them with all the equipment. New friendships and new alliances were formed, and some years later, these gave birth to a company which we called Erigo, which means to build in Latin. We formed this company specifically to focus on the design of hospitals and healthcare facilities in the international market. Hospital design brings together a lot of disciplines: architects, civil engineers, electrical and mechanical engineers, and contractors. These are the main stakeholders which you will find in most construction projects. In hospitals, however, another discipline is very commonly found, that of medical planners or medical equipment planners. These are most commonly medical engineers with experience working in hospitals, and they act as the bridge between architects and the building services engineers and the medical world. Particularly since hospitals have very specific design standards and guidelines. Most architecture or engineering firms would not have in-depth knowledge of these standards unless they've acquired them through many past projects. And thus, medical planners help to navigate the particular requirements that such projects bring about. Medical planning and medical equipment planning processes resemble the design processes of architecture and building services. The first step is typically to prepare a space program, which is a list of all rooms required for specific functions, along with their quantities and envisaged size in square meters. Together with architects, this space program is developed into an interior layout design to draw out all the rooms, corridors, foyers, waiting areas, etc. in the hospital. This is a process which is very important and where the medical planner guides the architects to ensure that proper patient flows are being respected in accordance with international guidelines. In some cases, we use special simulation software to actually simulate patient flows and to evaluate what might be the most efficient route or process to get, for example, the most scans per hour out of a CT scanner. After an initial draft hospital layout is prepared, The medical planners then prepare a bill of quantities for medical equipment, along with specifications for the said medical equipment. These deliverables serve a dual purpose. Apart from being subsequently used for procurement purposes, particularly if the hospital goes to tender for acquiring its equipment, they are also used at an earlier stage to guide the architects and engineers into planning their own BOQs and specifications. For instance, for construction material, electrical cables, pipework, plant equipment, etc. The BOQs and architectural layouts lead us, therefore, to the next stage, that of preparing and drafting detailed room layout sheets for key rooms within the hospital. Key rooms would be important rooms in the hospital that typically repeat themselves very often. For example, patient beds, patient rooms, examination rooms, theaters, potentially. So these room layout sheets are detailed AutoCAD drawings that show all the furniture, all the equipment, and all the building service requirements that the room needs for its own specific clinical function. These drawings often guide the building services engineers in calculating their demands for services and to design accordingly. Medical planning is an amazing profession, and it has allowed me to travel to all parts of the world, meeting new people and experiencing different cultures. To date, we've helped design hospitals in China, Jordan, Saudi Arabia, Djibouti, and Rwanda in Africa, and of course in Europe, in Cyprus, and in Poland. A third facet of biomedical engineering is, of course, research and design of new biomedical devices and software. This part of my career takes me back to around 2 or 3 years into my role at St. James. I was approached by one of my university professors, who is here today, and with whom I have a great relationship. He was in the process of setting up a new research center at the university focused on biomedical engineering. It would be called the Center for Biomedical Cybernetics. And my professor wanted me to be part of this. It seemed like an opportunity that couldn't be missed. So, for a span of about 6 years, I dropped my work at St. James to part-time and moved in full-time at university as a research engineer to help set up this center and participate in research projects. I would also use this time to finish my master's and start and complete my doctorate in biomedical engineering. During my term at the Center for Biomedical Cybernetics, I was involved in several projects. So I wish to share and describe some of the work that took place and still takes place here. Having a personal interest in medical imaging, my own projects were always related in some way to medical images and imaging algorithms. My first project was related to capsule endoscopy. Most of you will hopefully not be familiar with the regular procedure of endoscopy, which entails the insertion of a long, flexible instrument called an endoscope through the intestinal tract of a patient to be able to examine the stomach, small intestine, or large intestine. A more convenient procedure replaces the use of this flexible instrument with a small capsule which the patient swallows. The capsule contains a camera and a transmitter which transmits the images to a receiver on the belt around the patient's waist. This procedure, although being admittedly much more convenient and less unpleasant, has its own limitations. It cannot be controlled to observe areas of choice, and it essentially just tumbles its way through the patient's digestive tract, snapping pictures of whatever comes in front of it. Another limitation it presents is that sometimes it is difficult to discern which part of the intestine it is located in. So my work here involved designing and coding an algorithm to detect and classify the images that it took according to the part of the intestinal tract that it was in. This allows the doctor to better orient himself while reviewing the video of the capsule. For my doctoral studies, I focused on a different imaging application, that of ultrasound imaging. Here I explored the use of ultrasound for a routine ultrasound screening procedure. Ultrasound is often used to assess the thickness of walls in the carotid artery to quantify any presence of atherosclerotic plaque, and subsequently any narrowing of this artery. With enough occlusion, this may lead some patients to develop a stroke. In this work, I researched the use of artificial intelligence-based algorithms and would go on to design a neural network that would automatically identify the carotid artery in the ultrasound image and would automatically identify and measure any volume of atherosclerosis present. My colleagues at the center have worked on other interesting projects. My colleague Natasha here will present some of her work on brain-computer interfacing, for instance, which harnesses EEG signals from the brain to control practical devices, such as a wheelchair. The benefits that this could bring for those with impaired mobility would indeed be significant. A great deal of work has also been done using thermography imaging to screen diabetic patients, or else to use eye gaze tracking to control devices and computer cursors. It is research projects like the ones mentioned above, starting in a university laboratory, that eventually catch the attention of manufacturers and eventually make their way into the markets as fully commercialized products. For this reason, I feel that it is very important to continue to support research and innovation at the University of Malta. In conclusion, engineering and healthcare, is it really a life-saving combination? I believe that we all agree that healthcare would not be where it is today without the great engineering advances that have made it possible. The intertwining of engineering and healthcare heralds a transformative alliance, one that has revolutionized medicine and redefined the landscape of patient care. The field of biomedical engineering offers a rich tapestry of opportunities. As I reflect on my own journey through the various dimensions of this field, I am very grateful to have had the privilege of being able to contribute. From the halls of academia to the corridors of hospitals, each chapter has given me invaluable insights and shaped my understanding on the impact that we can wield when we are united in the pursuit of a common goal. Thank you very much.
Thank you, Dr. Azzopardi. I do have quite the tract for your camera, if you wish. A Formula One, as the minister mentioned. What follows now is a series of technical presentations focused on the research aspect in healthcare. Kicking off is a presentation about BrainCon project, which focuses on developing an intuitive brain-controlled wheelchair, which would enable the user to control the direction and speed of the device in a hands-free manner. Let us therefore welcome Dr. Natasha Padfield, Systems Engineer at the Center for Biomedical Cybernetics at the University of Malta.
Hello, good morning, everyone. So I'm Natasha Padfield, and I'm from the Center for Biomedical Cybernetics. I'm going to be talking about BrainCon, user-intuitive continuous brain control of a smart wheelchair. How do you change the slide? Okay, sorry about that. So let's start with a bit of a project overview. So our aim is to develop an intuitive and robust control of a wheelchair. So by intuitive, I mean that the user has to feel that the commands are natural to them, and by robust, I mean the system has to be reliable. The subjects use mental activities to exert commands, and we have 5 commands in our system. Turn left, turn right, speed increase, speed decrease, and the no change state, where the subject is idle and not executing any commands. The top image shows a picture of our brain signal recording equipment. It's called electroencephalogram, EEG for short. Basically, we put a cap on the head of the subject. The cap has holes, and we place sensors inside the holes to read the electrical activity on the scalp. The bottom image shows the wheelchair that we're actually using, which was previously developed by the Department of Systems and Control. So let's talk a bit about brain signal nature. So inside your brain, the different parts of your brain communicate via electricity. And that electricity travels from its source in the brain, through other regions of the brain, through the skull, onto the scalp. And we can record it using those sensors shown on screen, and it manifests as microvolt signals. So for each of the sensors, we have a signal. Now, how do we process and get useful information from those signals? So we reduce the multi-channel time series data to a feature vector. So what can those features be? They can be frequency features, time domain features, spatial features. Those features get fed into a classifier, which is like the brain of our system, which identifies what command the user was giving. And the classifier will output probabilities for each class. So here we have 5 probabilities being shown because we have 5 classes. The class with the highest probability is the command that will be selected. Now, EEG data is very noisy, so it's prone to sporadic misclassifications, and we don't want that in our system because it leads to jittery performance. So generally, the classifier, when someone is executing a command, say a turn left command, will output a high probability for that command. However, sometimes, due to that noisy nature of the brain signal data, there will be drops in the probability, which I'm showing with red boxes on screen. And that leads to a misclassification and poor performance. So our solution is called MPFS, Multidimensional Potential Field Smoothing. Multidimensional because we're dealing with 5 dimensions. Previous works have been mathematically limited to 2 dimensions, so just 2 commands. And by potential fields, I'm referring to an area of control theory which inspired this approach. So if we go through the variables, YT is the smoothed probability, so it's our smoothed output. XT is the classifier output, so those raw probabilities we're dealing with. Key and phi are just constants which need to be tuned, and they have values between 0 and 1. F3 is the free function, and that pulls the smooth probability towards its value at the previous time step, so YT minus 1. And FBCI pulls our smooth probability signal towards the current classifier output, XT. So if we go to the equation, which summarizes our work, we have the output, the smooth probability, at this time is equal to its value at the previous time step, plus some change. And that change is scaled by key, which is a constant, as I said, and it's a balanced sum of the free function acting on the value of the smooth probability at the previous time step, plus the BCI function, FBCI, acting on the current classifier output. Now, the plot on the other side of the screen shows how our MPFS approach, the blue bars, performed compared to comparison approaches in the literature, which are the other colored bars. We're showing results for accuracy for 9 subjects labeled G1 to G9. And you can see that our approach, the blue bars, outperforms all competing systems in all of the subjects. Now, previous approaches have tuned their parameters and their algorithms using heuristic trial and error methods, which are very time-consuming and limit the amount of parameter values we can experiment with. So we wanted to develop an automated and interactive tuning process, and we did this through reinforcement learning. So how this works is the subject is asked to execute some commands. We classify those commands using the current parameter values of the MPFS algorithm, And then we reward or penalize the parameter values depending on whether they led to an improvement in performance or a decrease in performance. And that's the reinforcement learning aspect. So I'm going to talk a bit about the EEG paradigm. So how do we issue commands in this system? So there are two popular approaches in the literature. There's motor imagery, which is the most popular approach, and that involves imagining movements. For example, imagining a left-hand movement to turn the wheelchair to the left. But it gets a bit counterintuitive at some point when you have to imagine tongue movements to increase the speed of your wheelchair. Now, why is motor imagery so popular? Because when you imagine movements, there are very strong signals generated in the central part of your scalp. Now, when we talk about speech imagery, we're talking about imagined words, which is more intuitive than imagined movements. For example, you would think the word up to increase the speed. We decided to develop a hybrid paradigm with 2 commands from motor imagery and 2 from speech imagery. And we also did an automated command selection approach where we customized the commands to the individual. And our hybrid approach was 21% better and 36% better than pure motor imagery and speech imagery approaches in terms of accuracy. So our research participants in this project are individuals without mobility issues, but also people with significant mobility issues. We've worked with patients at Stoke Mandeville Hospital, a leading spinal cord injury rehab center in the UK, to interview them about their views on brain control devices to inform our research. And we're currently working with people at Karen Gregg to recruit patients for our final testing sessions with the wheelchair. So what does an experimental session look like? So the participants will arrive and will record some training data. So they'll have a computer interface telling them to execute different commands. Using that data we've recorded, we train our classifier and perform command selection if we're going to be doing that. And then we have a user practice session. So the user will be told to execute some commands, and they will get visual feedback through a progress bar to help them practice and improve their command execution. Then we have the reinforcement learning tuning of the MPFS algorithm. And finally, we have interactive experiments with the physical wheelchair or in simulation for tetraplegic patients who cannot transfer to our wheelchair. So a quick word on exploitation. So we realized in this project that speech imagery is very challenging to decode. And so we developed the project SciDec, which has won MCST funding through the Sino Malta Fund, and that's an ongoing project. And the other project we've pursued is the MCST Commercialization Voucher Program. So that would be a project that's a direct continuation from BrainCon, and because we went through the CVP process, in future, we can potentially apply for technology development program funds to further our research on brain-controlled wheelchairs. Finally, a quick word on publications. So we've had 2 publications from this project, and 1 is currently under consideration at a journal. The review paper that we have, so the first one is open access, so anyone can access it, and it's about brain-computer interfaces being used to control dynamic devices like robots, wheelchairs, prosthetics, etc. The other published paper is our interview-based study with spinal cord injury patients about their needs and perceptions with regards to brain-computer interfaces, which we use to inform our work. And the submitted paper is on our hybrid paradigm approach and automated command selection. So thank you for your attention, and thank you for this opportunity to talk about our research.
Thank you, Dr. Petfield, for your very enthusiastic presentation. We all have that one friend who knows so much about your personal life who could ruin your career, so I'm very careful on how to introduce our next speaker. Please allow me to introduce Engineer Joseph Bohaja, Professor of Metallurgy and Materials at the Faculty of Engineering at the University of Malta, who will be presenting his work on the development and testing of biodegradable iron-based scaffold implant called Biosa.
I came from behind because I don't trust this guy. Okay, so the theme of my topic is scaffolds. And trying to understand. And the first thing that I will do is explain what a scaffold is. So this is a project that I worked on for a number of years together with my team. And it was a development of a material and also an orthopedic device. So let us start first with the application background. Why would one person would require this device? So if you have what is called a non-union fracture, okay, so a fracture which results in a gap between the bones, and this gap between the bones cannot be, you cannot have normal healing. So you need to introduce something in between in order to close this gap so that the cells, the osteoblast cells can grow within the bone, and then it starts the process of healing of the bone. There are a number of reasons why would require such an implant. For example, one of them is joint reconstruction, but also bone cancer is another issue where you would need to remove a large piece of bone because, of course, of an osteosarcoma, for example, cancer. And here we've got a quick representation, okay, of what we're talking about. So you've got a non-union fracture, so there's a gap between the bones which is large enough that it will not allow normal healing, and you place inside something which is called a scaffold. And the word comes from scaffolding because it will act as a bridge inside of the bone so that the bone cells can move through, and then you will have vascularization. So our project was to design the scaffold, okay, and also design the material for it. Of course, this is not possible. This was not done by myself, but was done by a large team of researchers, okay? So the BIOSA project is an interdisciplinary one, okay? So you require expertise in materials processing. In our case, we're using a process that combines 3D printing with powder metallurgy. Of course, this implant, as I will explain later, requires that it corrodes because it's a degradable implant, so you need knowledge in corrosion science. We had a number of people that were working on the corrosion aspect of the implant. Of course, you need knowledge in materials engineering because you would require the required strengths, and of course, the part on biology. So we had as well orthopedic surgeons on it. So this is what is called a paradigm shift because the implant needs to be biocompatible. It needs to have interconnected microporosity. Okay, this is a porous implant. And it needs to have the required mechanical properties so that it can support the bone structure, and at the same time, it biodegrades. Okay, so what is the basic principles behind the implant? So here we've got something which is completely not related to biology. So we've got the hull of a ship, and you would see the sacrificial anodes. We know that this is a process where the sacrificial anodes corrode before, of course, the hull of the ship. And this is the same principle of galvanic protection. Now, here we need to think opposite, okay? So we designed an implant which has a material in it which will corrode preferentially to the matrix. So the matrix is iron manganese. It's non-magnetic. That is required by the healthcare. And inside of it, there are chunks, which you can see there, in light color made from silver. Okay? And the idea behind this implant is that you will speed up the corrosion rate because you're doing the complete opposite to what we do to ship hulls. So we have the matrix corroding while the silver is acting as a cathode, okay? So the matrix as an anode and the rest of the material as a cathode. Of course, our design, the corrosion studies that we do is more complex than just, dipping a sample in a liquid and then see what it happens. So here what we are seeing in this slide, okay, we use a technique which is called electrochemical impedance spectroscopy, where we provide an AC current to our sample, and then we will model it using an electrical circuit, okay? So we will model it with resistors and with capacitors, which are not perfect. And simple here, okay, you will see a difference marked by the blue line and the black line. The second line is showing that there's another additional time constant in these both plots, and that means that something was forming on top of our implant, and that was a little bit problematic. Why? Because we were inside of the implant, okay, while the process of corrosion was going on, there was a calcium phosphate layer forming on top of the surface. This meant that our sacrificial cathode was being covered by this layer. We also proceeded in the development of the implant. So there is the problem, okay, so a lock of bone, which can be measured using CT scan. And then following that, we 3D print a polymer template with normal techniques. Okay, we were using a cell lay. Then we covered that template, which was sticky originally with iron manganese silver powder, and then we sinter, okay? So what does that mean? So we burn out the polymer template, and we end up with a metallic implant, okay? So this is a quick schematic of how the real process really worked, okay? And these are some images of one of the templates that we were printing. So we 3D printed the template with polymer. Then you can see on the second slide a coated template. So there's metal powder stuck onto the polymer. And the final part is a sintered metal part. So from a polymer, we changed it into a metal. Here we've got some microscopy, so the 3D printed polymer template. Here we are showing a gyroid type template. You can see here the metal on top of the polymer, and then finally, after sintering, you will end up with a replicated version of the 3D printed polymer template. We have, thanks to the funding body and to the Knowledge Transfer Office, we patented this technology. But we also then later on, we published a number of papers which were related to the processing and also to the in vivo testing of the implant. So in terms of to have a project like this, okay, you need a number of people working on this. So we were lucky to have a group of professionals working on this project. We had 2 orthopedic surgeons, okay, and another 2 orthopedic trainees, okay, so surgeons that are in the process of becoming eventually consultants. And we also had a medical doctor. Finally, we were testing the implant both in vitro and in vivo, and we were comparing the two together. So we used a rat animal model to where we implanted our implant in the vertebral bone of the rat, okay, so on the tail, and then we analyzed the corrosion, and we compared the type of corrosion that we were getting in vitro compared with in vivo. The majority of the work was also required that we tested the implant as well for corrosion, okay? So I had a PhD student working only on corrosion science of the implant, but we also took a glimpse at the problems with producing this implant. Manganese in itself, and you require manganese so that you change the implant to non-magnetic, because otherwise it cannot be implanted in the body. Manganese oxidizes very quickly, so we were seeing ways of reducing this oxidation reactions. I will stop here, and I thank you for listening.
Thank you, Joseph, for sticking to the subject. Our next topic is about cerebral palsy, which is a group of disorders that affects a person's ability to move and maintain balance. It is, unfortunately, the most common motor disability in childhood. Employing technology to combat this disorder by means of a smart wearable device, please let's welcome Engineer Philip Farrugia, Professor of Industrial and Manufacturing Engineering at the Faculty of Engineering, University of Malta, who will present his work on DigiClap.
So, good morning, everyone. I'm delighted to be here today to present our innovative device, DigiClap, a smart wearable device for children with cerebral palsy. Well, in this presentation, I will first go through the reasons which led us to the motivation behind this work, the overview of the device, including the hardware and software that we developed, the first findings from the evaluation studies that we conducted, and finally, we conclude. So, the motivation. As it was said, cerebral palsy is a physical disability which affects movement and posture, impacting daily activities such as eating, writing, dressing, and catching a ball. All these things, we take them for granted. It can manifest itself in the lower limb, upper limb, and both. This condition affects as much as 17 million people worldwide, being the most common physical disability in children. From some observations that we made, it resulted that the traditional habilitation practices do not provide a high-quality user experience for children. We also did a market research to see what's going on, options that are on the market. Here we are seeing some: Rapael Smart Glove from Neofact, Hand Tutor from Meditouch, and also the U-Grabber from U-Rehab. Upon seeing these devices, one can see that they look invasive, bulky, and also they don't provide a degree of customizability. So what we are offering? This is DigiClap. It aims to make therapy more interactive, more motivating. How? By engaging children with this condition in an augmented reality-based digital serious game. It also allows occupational therapists to remotely monitor the progress that the children are doing during the session as well as in between the sessions. Also, the movements of the individual phalanges, so not of the overall hand, are captured in real time and transmitted to a cloud. Taking a closer look on this device, we can see a lot of innovations. So let's start with the first one. It has adjustable rings for comfort and variance in the finger size. They are produced into materials, as I will explain next. It has the finger attachments which can be added or removed depending on the activity being conducted. A splint as well, which can be attached to the device depending on the needs of the end user. Because of course children have different abilities. And the device can be personalized according to the children's preference. In fact, in terms of manufacturing, we are resorting to 3D printing. More specifically, we are using a multicolor FDM printer, Fuse Deposition Modeler, the 3D printer. And we use this in order to print the rings, okay? Of course, the rings, they have sensors. We are using IMUs to capture the movements of the hand. And as you can see here, we are using two different materials. We are using the rigid PLA to hold the electronics and the IMUs, and also the flexible TPU in order to provide the comfort for the end user. We also explored the possibility of different printing strategies. So we use this project to explore a bit the possibility of having one of the heads of this 3D printer customized in order to pick and place the electronics. So you can stop the printer at a certain level, you insert the electronics, and you continue with the printing. Focusing now on the software, we have, of course, we had to develop the motion capture algorithm. It was modeled, mathematically formulated as well, and of course it had to be tested. So we used the industry standard reference Viking system to make sure the positioning, such as flexion, extension, matches when moving the hand and the fingers. And also testing was done with no distances to make sure that the fingers are correctly separated when grabbing. So here we are seeing different movements. That was the back-end software of the system, now the front end. As I mentioned, the intention of this device is to be used by children with cerebral palsy in an augmented reality environment. So the child wears the device, and he or she interacts with this game. We developed a number of games. This is the main menu of the game that we're currently developing. The next step would be an initial calibration. So this is would know where is the datum. So with reference to that datum, of course, all the measurements of the individual phalanges are measured. So the calibration is an important step. Once that is done, we have this menu of recipe selection. At the moment, we have 3 sort of sub-games. We have the burger game, pizza game, and cake game. They were designed with the intention to target a range of users. So if, for example, the occupational therapist would like to have the client who requires fine movements, then he or she will opt for the cake game. Why? Because the child has to decorate precisely the cake. Of course, if not that fine movements are required, then the occupational therapist can go for the burger game, because the child with some movements, he or she has to chop onions, tomatoes, and so forth. So that's where we are providing this degree of customizability. It's not just on the device, but also on the game level. Another game which was developed is a very simple game, throwing a ball for a virtual cat to catch. So this was augmented reality. So imagine you are catching a boy, throwing a ball. Here we have some examples. And the child could see a virtual cat moving on the physical table. In terms of usability, so what we did, we conducted 8 sessions with 6 children. It seems a small sample. It is a small sample, but unfortunately, to find people locally, it was difficult because of the current population of children with cerebral palsy, which is good. But in terms of validation, of course, we need further results. These participants were aged between 4 to 12 years, and each participant had different abilities. We had also 3 occupational therapists who observed the sessions to take qualitative data, and various data collection instruments were used in order to get feedback from not just children, but caregivers and also occupational therapists. So over here, we are seeing 2 sessions of children playing this game. As you can see with the movement that the child is doing, the ball is thrown to a cat, and the cat tries to catch that ball. Okay? This was the first game that we developed. We have another case study over here where, again, with some movement, we can see the ball being thrown to the cat, and the cat tries to catch it. So it's a simple game. Now, the findings. What were the findings? As you can see from this chart over here, in terms of overall experience of children, comfort on the device, child's motivation and also continued usage after trial all exceeded or very close to 100%. So 80, 100, 95, and 90. What is more striking are the testimonials. So over here we have summarized, we are presenting just 3. We have 2 parents and 1 occupational therapist. Besides the publications, besides the results, for us, at least for me, the salient point of this research was captured in that saying by a parent of a 7-year-old boy with cerebral palsy. So in a period of 8 weeks, this mother observed some improvement of her child. For us, that was a key achievement. Other achievements as a research team, what we managed to get. We presented DigiClap at the MedTech World Summit, which was held in Malta. This helped us a lot in the exposure of our technology with key players in the field. Foreign companies approached us to work with them. We are in the process of liaising with the Knowledge Transfer Office to see how we can commercialize the device. One of the companies is Alvarium Health. We also filed a patent, and we obtained a CE serial number of the device. On the research level, stemming from the design research activities that we conducted, we presented the results in peer-reviewed conference and journal papers. What are the conclusions? The first thing, the unique selling point of our device. It has modular finger attachments and the capacity to read movements of different phalanges, which we believe make collectively our device unique. As you have seen, the results are very encouraging, both in terms of ergonomics and effectiveness in the therapy. And from the feedback that we've got during even the MedTech, companies out there were seeing this device suitable also for other potential target audiences, not just children with cerebral palsy. We are speaking about Down syndrome children and also post-stroke patients. What's next? The validation of the research results, because with 6 children, of course we got positive feedback, but it's not enough. You need to get more data. So what we are doing at the moment, we are validating the results, the device, in Cyprus. We have good connections at Nicomet Rehabilitation Center in Cyprus there, and we are trying to get more results out there as well. Develop further the serious games, because after a while children get used to it, so we need to improve it, to develop further, and also exploit more the potential of augmented reality. Before I wrap up, allow me to make some acknowledgements. The multidisciplinary team. All this was not possible without a number of people. Here we have Matthew Bonello, who was one of the main researchers on this project. So we had a number of academics at university. Also, this project was done in collaboration with 2 local companies, Humane and Invent3D. And the team consisted of mechanical, electrical engineers, software developers, and occupational therapists. The Malta Council for Science and Technology, for funding this research. This project started now 4 years ago. We started off with the commercialization voucher program, then we moved to the TDP, and in the last 2 years, almost 2 years, the go-to-market to try to improve the technology readiness level of the device. Last but not least, the occupational therapists, children, and caregivers who contributed in the evaluation studies. That's it. Thank you for your attention.
Thank you, Professor Farrugia. Also joining us from the Faculty of Engineering at the University of Malta, I now pass on the stage to Engineer Thomas Chibiras, a PhD student researching MEMS, a gripper for biomedical applications.
Hi, good morning. I'm Thomas Chibarras, and today I'll be speaking to you about our project, Microelectromechanical System Gripper for Biomedical Applications. The project is highly transdisciplinary in nature. It's being supervised by Professor Pierluigi Mollicone and co-supervised by Professor Ivan Grek from the Faculty of ICT. Our extended core team also consists of Dr. Maria D'Amicoli, Professor Bertram Mallia, and Professor Nicholas Sammoud. The background to the project is that currently single-cell mechanics is a subject of interest globally, as is the development of a cheap, simple-to-use single micro-object characterization tool. And this interest stems itself from the fact that there exist certain biomarkers of quantifiable magnitude that shed light on certain pathological conditions. For instance, sickle cell anemia as well as diabetes are known to give a considerable increase in a single red blood cell's Young's modulus or stiffness. Other than that, there exist other miscellaneous functions such as prior characterization of calibration microspheres, as well as other microassembly tasks, not necessarily biomedically related, that may require such a tool. So the scope of the project is essentially to design and develop a tool suitable for the mechanical characterization and manipulation of soft, temperature-sensitive micro-objects, in particular red blood cells. The device must be able to do so in fully submerged conditions, and we are to make use of commercially available fabrication processes. In this project, we made use of what is known as the SOIMAPS process, a silicon on insulator process. It is a simple 4-layer stack, and electrical and mechanical routing are possible on a 25 micron thick doped silicon layer known as the SOI layer. The activation mechanism that we implemented in our devices is electrothermal in nature. And we made use of a driver known as a V-shaped driver, which is composed of two mechanically clamped anchors interconnected by a series of floating beams and a central shuttle. It operates as follows. So a potential is applied across the anchors. As such, current flows through the semiconductor, and therefore we get Joule heating. This gives rise to an increase in temperature at the semiconductor, and therefore thermal strains and a displacement parallel to the floating shuttle. When two such drivers are placed opposing one another and interconnected by another passive driver, which is also floating, we get what is known as a cascaded V-shaped driver. And to this, other tertiary amplification mechanisms are possible. Within this project, we designed 7 unique devices. Not all are being shown over here. However, just for some perspective, each one of those has a planned footprint of approximately 1 millimeter squared. The devices were modeled numerically in ANSYS. The simplest numerical modeling technique that we used is what we refer to as a sequentially coupled method, where we discretize our geometry first in an upstream module, whereby the geometry is discretized into elements having electrical and thermal degrees of freedom. Here we calculate the Joule heating phenomena, and the increase in temperature is then transferred to a module where the structure or the device now has structural degrees of freedom, and here we can calculate the displacements via the thermal strain from the results from the upstream module. The most interesting is the final numerical modeling method. It is what we refer to as a fully coupled electrothermomechanical numerical model, where we can discretize our geometry, our device domain, into elements having electrical, thermal, as well as displacement degrees of freedom. We also model the fluid here as a finite volume, however, not infinite elements. And here we can solve for the fluid structure interaction phenomena happening around the devices. This is a typical device and fluid domain. Note that the fluid domain is much larger than the device domain. Here we can accurately or more accurately calculate the heat transfer phenomena. We also tested the devices experimentally at the MEMS testing facility at the Faculty of ICT. We tested our devices in air, DI water, as well as saline. More often than not, the test subject, if it is a cell, will probably be in some sort of a conductive fluid. Moving on to some results, these are typical temperature contours. On the left, in the finite element or in the device domain, and on the right in the corresponding fluid at a section midway through the device thickness. Now, the temperatures being shown over here are too high. This is for operation in air. We do not want such temperatures in, for example, water. We want to stay well away from the boiling point of the fluid in the entirety of the device. However, at the tip or where the characterization procedure shall happen, we obviously want, or we would like the temperature of the device to be as close as possible to the ambient temperature so that we do not damage the test subject. Here is a tip displacement versus RMS voltage graph for one of the devices in the DI water and sodium chloride solution. We're very happy with these results because we can see a very good correlation between experimental and numerically derived results. So throughout this project, we have published a number of our findings in journal papers, as well as we also had the opportunity to present our work in MEM-specific conferences. Now, moving forward to successfully characterize a cell or anything, we would also need to incorporate a subject positioning mechanism of sorts and also a force sensing mechanism. All we have seen so far is just an actuator portion. And that's all from me. Thank you.
Thank you, Engineer Xiberras. Moving on to the ICT front of engineering, let us please welcome Dr. Konrad Attard, the Deputy Dean of Computer Information Systems at the Faculty of ICT at the University of Malta, presenting his research on pervasive electronic monitoring in healthcare, a project which aims to enhance the quality of life for people with dementia by supporting them in their everyday activities and fostering their social interaction with caregivers, family members, and others in their community. Dr. Attard.
Thank you very much for the invite. It's not just one project. Actually, it's different projects which are being done over the year. And I'm having the opportunity to give a brief overview focusing on particularly two. So we aim to improve the quality of life through technology in a context which is a very sensitive concept because we are dealing with the elderly, focusing on dementia. The benefits of this research is not just within that area, but it gets a bit more complex due to the nature of the area. We are collaborating with a number of countries who are investing, particularly not only in the research, in the ICT research, but also in different areas. This is multidisciplinary, and we therefore need insights from professionals, especially people that work closely to these people. Our target is personalization. So it's not just about being able to find one that fits different aspects, but even to target the needs of individuals. Therefore, the role of pervasive electronic monitoring with the context of learning more about the people that we are dealing with is obviously beneficial to achieve the personalization that we need. Norway, Portugal, Belgium are partners in these projects where they are helping us at the University of Malta to get funds, use their resources, and apply this little project that we had started to scale it up and make it more viable. So this is just a bit of an overview. Particularly, which was key, is the data set that we created. We focus on human activity recognition. So our aim is to learn the activities that people with dementia would be doing. The target is actually healthcare professionals and family members, where the tools will help them to assist what they do already. The data set is critical because, as it implies, you can't simply monitor the elderly or particularly people with dementia and expect that certain activities are done, particularly the dangerous ones, the ones that we're targeting for, the ones we would like to predict, to anticipate, or rather to give the opportunity for them to live a bit normal without restricting them. Now, this requires skills, and one of the bigger challenges is that sometimes in our research, we have people that follow a degree course, do research for a certain amount of time, which is a very short amount of time. In this context, the learning curve, or the time where you start maturing into the area, is probably the time you are completing your research or your reports or whatever. So in digital health, we have created a course, a full-time and part-time, with the aim to have more people learn about these subjects and learn the language, but is both ICT and obviously the healthcare aspect, giving opportunities then to apply the research. So 50% of the work that they do is applied and therefore creates opportunities for them to make the subject more relevant. There are different aspects that we can see that basically healthcare professionals lack in expertise, the resistance to change in the context of digital health, data security issues, liability issues, data transfer, all these come to play. So it's not just about pervasive electronic monitoring. Now let's focus a bit about the subject which we are focusing is the dementia. The numbers are increasing. The costs will increase to 2.8 trillion worldwide by 2030. As yet, there is still a lot that needs to be done. One of the main focus problems is falling. And falling is not a trivial problem to solve. In Malta, the target, unfortunately, is almost over 14,000, which is a high number. We therefore collaborate with Save This in Nepal, and we address issues which allow us to complement the work they do, but at the same time get feedback on all the type of solutions that we create. So earlier on, you were seeing the timeline of different projects. Our challenges are not limited in designing visualization tools that help professionals, but there are situations where collecting data from sensors becomes critical. If we are dealing with issues that we would like to predict, real time is a key aspect. The fact that we are addressing problems such as the latency, the delay between the sensors that we collect and the reaction, which is basically the actions that the healthcare professionals need to do, plays an important part. So our lab, we have different aspects that we tackled, including the use of edge servers to be able to optimize that. Looking just at this graph, we can see the challenges of the funding versus the comparing to other different chronic illnesses and the effects towards it, which unfortunately we still need to do much more in this area. There are limited resources for carers, so this is very obvious, evident every time we are working, not only locally but internationally. We see that the digital aspects are very limited. Therefore, tools to support them need to be there, and therefore a new challenge comes about. Most of the time it is that there is lack of education too, which is the exposure to the digital tools and how they can help them. Through studies that we've conducted, there is a consensus that these tools will help them, but unfortunately there is a question of how will they help them. They have vague ideas, they have ideas of how this can be implemented, but lack of exposure. To address this, in our studies, which we had over 100 participants that came over donating an average between 2 or 3 hours, we included an education and training aspect, which basically allows us to give a bit of an experience through a special suit which replicates how an elderly would feel, with different aspects which vary according to the type of person we are profiling in that context. Because as I said earlier on, we can't just go and study the elderly because that context is very difficult and to replicate. So instead, we invite healthy people to participate, and therefore they wear the simulation suit. As a result, they can feel empathy and understand that condition, but learning about how the digital tools can help them and know more about the solutions that we're presenting. We try to work independent from the sensors that are available, because we know that every year and every opportunity there are new tools that we can adopt. And therefore, our solutions, algorithms, and designs will try to maximize according to the devices that are available. So there are over 21 activities that we have identified through focus groups, and we replicate them in our lab. So the data set, in actual fact, makes it possible that one of the gaps that is in this area is the availability of realistic data sets that replicate the real environments of these people. So most of the data sets would focus on one activity, and that type of activity is not put into a natural context. Therefore, we did this data set, and through a number of participants, we managed to achieve already 30 to 35 participants, which we can use this data, which replicate, and therefore can be used for research. As I said, predicting falls is not that easy. It's quite complex and not trivial. For different reasons, the environmental factors, physiological factors, data limitations, and the dynamic nature of this risk. We have more than 47 professions which are on board, and we have collected valid over 70 participants. 35 of them are being labeled as we are speaking, which means over 5 million records that are actually being recorded and labeled for all the types of movements that they are replicated in our labs. My last slide is basically focusing on the edge computing, which is, we've published some work where we have managed to design algorithms through a framework using edge computing, which allows us to improve the latency and one of the major issues in such an area. So future work is not only to focus on individuals, but groups, but we have an ambitious project through our PhD students and Masters by Research, where we're addressing how this data that we're creating can be recorded, particularly to address incomplete data and limitations when data can't be interpreted, because when you're modeling one individual, that can be an individual, a challenge, and therefore that is one of the areas we're focusing next. Thank you very much, and if you need more information, feel free to reach out to us.
Thank you, Dr. Attard. It is encouraging to see such developments and research in healthcare. Unfortunately, as many of us have experienced, one major limiting factor for any research work is usually the availability of funding. Providing a little solace for us today, let us please welcome Mr. Stephen Borch, the Deputy Director of the R&I Unit at MCST, as well as his colleague, Engineer Mark Mela, Deputy Director of the Framework Program Unit, who will present some valuable information regarding the availability of both national and EU research funding opportunity. Please.
So, good morning. My name is Stephen Borch. As was mentioned, I'm the Deputy Director for the R&I Unit. I work at MCST. Now, what is MCST? MCST primarily is a research funding organization. So we provide the support for research projects and Maltese researchers and entrepreneurs for their novel ideas to be developed and to eventually hit the market. We already heard from a few of the projects that we've already provided support for. So, for example, the projects of BIOSA and DigiClap. So, I primarily come from the R&I unit. The R&I unit makes use of national funds, so Maltese taxpayer funds. As of this year, we have a budget of about 10 million euros, and mostly that is dedicated to the Fusion program. The Fusion program is a portfolio of programs, so it's a various different programs that focus on trying to support you at every stage of product development. So all the way from the initial idea, the initial concept, all the way down to the point at which you have to commercialize this and actually take it to the market. Fusion has been in operation since 2015, and up until date has given about 23 million euros worth of support. So these are all of the different programs that exist in the Fusion portfolio. Most researchers are going to start at the Research Excellence Program. This focuses on very early stage basic research where you just have an idea. You don't necessarily have to have anything concrete at this point, and provides about 80,000 euros worth of support just to develop that initial sort of proof of concept, just to show that the idea in theory will function. It moves to the CVP. The CVP is a feasibility study, and we see that your market is genuinely novel and genuinely can be taken to the market. And this is held in conjunction with a list of approved service providers who are going to help guide you and help you to focus your idea in the manner in which it should be developed. The CVP currently acts as a prerequisite for the TDP. The TDP is the largest grant that we offer, which is of 300,000 euros, and is for a consortium of a public and a private entity to work together to actually develop a fully fledged prototype, a sort of minimum viable product that you can showcase and hopefully get some further investment and some further interest going in the project. And the go-to-market, somewhat self-explanatory, is a program that we currently run in collaboration with the Malta Development Bank to help you develop a sort of small startup operation focused on this technology that was developed so it can be carried to the market. There are some satellite programs that help and provide alternate routes. There's a TDP Lite, for example, which is for faster moving technologies that might not be able to protect themselves by getting a patent or some kind of IP, but really need to get to the market as quickly as possible to corner that market. There is the Technology Extension Support Program, which helps private entities seek support from higher education institutes and have a small scale project that is going to focus on optimizing some product that they may already have but need to optimize. And there are the thematic programs. So once a year we launch a scheme dedicated to a particular theme. So for example, this year, and it is currently open, it is the Digital Technologies program, for example. And last but not least, and not represented in the slide, is the Research Networking Support Scheme, formerly known as IPES, which should be launching today, which helps entities both collaborate with foreign institutes of repute and will also support them publishing in an open access peer-reviewed journal. Moving to another unit, the internationalization unit. The internationalization unit does very much what the R&I unit does, but has an international dimension. So they focus on working with foreign collaborators and foreign stakeholders to make an underlying infrastructure through which researchers can collaborate with other researchers from other countries. They do so by either through bilateral collaborations, which they have with China and which they have with Turkey currently, and are constantly trying to expand this portfolio, and they do it through multilaterals. A multilateral which is very relevant today is the Transforming Healthcare Systems. So this is a partnership dedicated to adapting the current healthcare systems that we have. I am now going to hand over to my colleague, Mark Mela.
So, good morning, everyone, and thank you, Stephen. So I come from the Framework Program Unit, and I represent the Horizon Europe program. We are a team of NCPs, and we all cover the different areas of the program. I hope that by now you got involved with first of all, with the name itself. I think it's been now for 4 years running. The program is one of the most illustrious program with 95 billion covering 7 years. It started in 2021. It will finish around 2027, and is actually covering all the areas of research and innovation. In my own experience as a national contact point, I have never ever met someone that told me that they never found an area that they cannot collaborate in. Especially today, since the theme of the event is health, there is even a thematic program under Pillar 2, which is actually focused on just health technology and research and innovation. The program is split into tiers or pillars. The first one is mostly focused on the mobility on researchers and also how to create research teams through Marie Curie actions, even supporting them to the research infrastructures. Then there are the thematic areas. For example, health is one of them, culture, security, digital industry and space, climate, energy and mobility, you name it. So there is a lot of thematic areas that you can, in a way, get involved in. These are covered by work programs. Work programs cover nearly 2 years, 3 years, and they are always calling for consortia to join forces to come up with a research idea that is satisfying a European need. The third pillar is mostly focused on these disruptive companies that are coming up and creating new markets. There's the EIC Innovation Council there, which is actually supporting these unicorns. And basically, having said that, you will find any type of research and innovation scenario that can be funded through the whole program. So, sorry. Going back, sorry. Sorry about this. Sorry about this. So obviously there are some eligibility criteria. As long as you registered in Malta, you can participate. Usually the calls require at least a minimum number of entities to be involved, which are coming from 3 different countries. In this case as well, for public entities, there needs to be a gender equality plan in place, but in the case that you are a private entity, there's no need. So obviously the intention of these kind of projects is to have collaboration even between different countries. The actions that are found within the program usually cover the different number of TRLs. For those that do not know what TRL level is like a scale to gauge the technology readiness level of the research idea. So under research innovation action, you will fund 100% both public and private entities, because the TRL level is still very, very in the early stages, because new knowledge needs to be uncovered. Then you have the innovation actions that are focused mostly on creating and demonstrating the technologies that were developed in the first stages through the demonstration and so on, even in situ environment. So here the funding rate is 70% for the private sector, but still 100% for the public entities. And finally, you have the coordination and support action, which are mostly focused on networking, knowledge sharing, and so on. In this case, you can be even a mono-beneficiary to take part in the kind of project. One important thing to mention about this is the funding rate as well when it comes to indirect costs. So if you're a private entity and you're involved in a research innovation action, you'll get 100%, and then you get another 25% to cover even indirect costs to, for example, rent, water, electricity, and so on. So it's a very advantageous program, even when it comes to funding rate. So how to find the calls? Ideally, if it's your first ever experience in the program, kindly get involved with us. The NCPs can guide you throughout the process. We have even support schemes that help you even in terms of networking, proposal writing. So actually we provide a one-stop shop of activities to support you in the program. There's the funding and tenders portal, which is the actual main portal of all different activities coming from Horizon and even beyond. So I suggest that you go there and even type a keyword of your interest to find the topics coming up as well. And then also there's the work programs. But yet again, if it's your first ever experience with Horizon, I suggest that you get in touch with us. So what does Horizon fund? Mostly personnel costs, so the time of someone, a research team, and that is actually working on the project per itself. There are some subcontracting costs, but usually that's limited, travel and subsistence, and other costs that are obviously related to the type of activity in the call per se. And yet again, another 25% cost is always covered in all actions. And that's it. Thank you very much.
Thank you, Engineer Mela and Mr. Borch, for your valuable, pun intended, contribution. It has been interesting to note how much of this research has been initiated and is being executed locally. But how can such work grow, develop further, and be internationalized? Taking us towards internationalization opportunities, sorry for messing that up, is Mr. Carl Gauci, Senior Business Development and Outreach Manager at Tech.mt.
Hello. Good morning, everyone. So today I'm here to speak to you a bit about how you can, as engineers, internationalize your concepts, your ideas, your solutions, and we're here to present just that today. So Tech.mt, together with some other entities, together with Malta Enterprise, Finance Malta, Gaming Malta, and the Malta Digital Innovation Authority, banded together last year in 2023 to create a brand called In Malta, which is now serving to promote Malta overseas in conferences and events. So we're now providing a more targeted approach when we're representing Malta overseas. And through In Malta, we're also able to give an opportunity to companies to promote themselves on an international level because, as we have seen today, such solutions are infinitely scalable and, of course, shouldn't be limited to just Malta and Gozo. Starting last year, we've been already to a couple of business missions. Last year, we've had our first 4. We've been first to Dublin Tech Summit, which served as the launching pad for In Malta, for the brand. Then we proceeded to Money 2020, GITEX Global, and Web Summit. As you can see on your screens there, you have a couple of photos which show you how we are structured. So there's a main pavilion, which is branded under In Malta. So we're actually given Destination Malta a lot of traction here as well. And we have also mini booths within the main pavilion where companies can come in and literally plug and play. We take care of all the logistics and everything else. Companies literally have to just book their flights, accommodation, and turn up on the day. This year, we are holding 5 business missions in total. 4 of them will be led by the entity that I represent, Tech.mt. The other one will be led by Finance Malta. We're starting at Dublin Tech Summit between the 29th and 30th of May, which is quite soon now. Then we have, we'll go to Money 2020 in Amsterdam, proceeding to London Tech Week between the 10th to the 14th of June. And then in fall, in autumn this year, we're going to GITEX Global in Dubai and to Lisbon for Web Summit. Those, I think, are some of the largest tech events in the calendar year. For upcoming business missions, we've managed to attract quite a healthy number of companies that will be joining us at the delegation to promote their business overseas. We ensure that the businesses that join us have the minimum work that they need to do. We take care of all the logistics, as I've already said. We provide everything that they need. So companies just have to come, network, and we also
take care of organizing happy hours to attract additional footfall at the stand. And furthermore, we also secure speaking slots to promote Malta and of course, the delegation that is joining us. Next Monday, actually, we will be launching the expressions of interest for our next 2 business missions for this fall. So if you'd like to be one of the companies to come to either GITEX in Dubai and Web Summit in Lisbon, you can reach out to us. At the end of the presentation, you'll have my contact details as well. And we'll be more than happy to have the discussion with you and understand where you are and where you want to get, and whether we can discuss whether one of these events would be suitable for you to promote your brand. This is just a quick slide to show you how we'll be structured this year. This is the pavilion that will be representing Malta across these 5 conferences. It will be a reusable concept, so we'll be able to scale this and add and remove as need be. And as you can see on your screen, we have a reception area where governmental entities will be based, and then mini booths where companies can come and plug in and show the services on the laptops, and where you're seeing their gaming mall in Malta, all those logos will be replaced with the companies that will be joining us. That's another top-down view. This you can see from the front. We have a reception area, and at the back we also have a seating area which doubles as seating. People can meet there. And we also have some packages for those companies that perhaps do not require a stand, but just want to come, roam around, and use the space to network and meet people and engage in conversation. Apart from internationalization opportunities, Tech.mt is also able to guide businesses across a number of different funding and support measures that exist here locally. So Tech.mt collaborates with a number of different entities locally, like Malta Enterprise, MCST. I've seen Stephen and Mark talk before me. Business Enhance, Malta Development Bank, MIMCall, so we understand what is available. We're able to sit down with you, understand where you are and where you want to get with your current entrepreneurial journey, and we're able to pinpoint you towards the right direction. We're also able to guide on EU level support measures. Tech.mt serve as the national contact points for Digital Europe program as well. So we're able to guide companies looking to form part of any of the current open programs under the DEP. We also offer a consultation initiative which is backed by over 45 local and international companies. This has stemmed from our communication with company, our outreach with companies, and startups often tell us that they have unique, innovative ideas, but in order to take these ideas forward, they require not only funding, but also expertise, knowledge from already established industry players. So we've partnered up with industry players in order to provide pro bono consultancy services to companies. You can see the areas of consultation there, where ranging from, so the way it's structured to entertain companies from very early stage startups to more mature startups. So as you can see, we can provide consultation in concept validation, market assessment and go-to-market strategies, consultancy on emerging technologies, digital marketing, digital transformation, e-commerce, and internationalization as well. This is provided by over 45 industry leaders that you're seeing on screen. If you'd like to avail of this opportunity, it's open for startups, but also students that have an innovative idea or concept. I invite you to reach out to us. And how do businesses and individuals keep informed of all of this? We've constructed a business directory, which is, again, free of charge for businesses to join. And the benefits of being part of this directory, it's over 400 companies strong. We started this 2 years ago. You'll be able to showcase your innovative solution online, which we promote as well overseas on our conferences. You're able to stay connected with like-minded individuals who are quite active as well locally, apart from overseas. Our first event now bringing together the tech ecosystem will be in July, but we'll have a couple of other events scheduled throughout the year. And you will also, by being part of the directory, you will be informed, you can stay informed about the latest developments that Tech.mt has. That is it. Thank you. My details are on screen. If you'd like more information on the internationalization opportunities, the business directory, consultation initiative, or you would like to sit down with us and discuss which funds and support measures are best suited to you, please reach out to us, and we'd be very, very happy to help you. Thank you.
Thank you, Mr. Gauci. It has been a very intense yet fulfilling session so far. A warm appreciation to the previous 8 speakers for their very significant research and work. Thank you very much. We can afford a few questions before our coffee break, should anyone wish to partake. Only a few, though. Well, everyone seems to be a bit hungry. So it is now time to move a bit, and so let us head for a short coffee break and some delicacies prepared for us by the culinary team at Hotel Excelsior. I kindly ask you to be seated by 11:40. Please remember, Marcel's guard dogs haven't been fed yet, so please be punctual. Thank you very much. Ladies and gentlemen, welcome back to the conference. We hope you are all well charged and coffeeed up. During this first session of this conference, we sought to expose some of the most innovative work of engineers in healthcare, as well as providing some valuable information to address the challenges of funding and internationalization. I got that word right, finally. Moving on, we have now prepared for a panel discussion and invited a number of distinguished stakeholders in this field. Allow me therefore to introduce to you the discussion on the impact of innovation on the future of healthcare. Please, let's welcome our distinguished panelists, Ms. Celia Falzon, CEO of Mater Dei Hospital, Engineer Joseph Sammut, Chairperson of the Malta Life Sciences Park and Council Member at the Malta Innovation Forum, Professor Jean Calleja-Gius, Professor of Anatomy at the Faculty of Medicine and Surgery at the University of Malta, the multi-talented Dr. Tatjana Kirkop, the Deputy Principal of Research and Innovation at MCAST, and Dr. Engineer Anton Bartolo, Director of Corporate Research and Knowledge Transfer at the University of Malta. Moderating this panel today, please let's welcome Dr. Ingrid Gallia, Lecturer of Artificial Intelligence at the Faculty of ICT at the University of Malta. On to you.
Thanks. So, good afternoon, almost, everyone. I am Ingrid, and it is my pleasure to welcome you to today's insightful discussion on the impact of innovation on the future of healthcare. Today, we have gathered an esteemed panel of experts who will share their perspectives on how emerging technologies are shaping the future of healthcare. Our aim is to explore the boundaries of innovation, from artificial intelligence to personalized medicine, and understand how these advances can transform patient care and healthcare systems globally and locally, especially here in Malta. So let's dive into an engaging dialogue, and let's begin by addressing the technological forefront. Engineer Joseph Sammut, can you share with us how emerging technologies like AI, machine learning, robotics could revolutionize healthcare practices?
It might be, are you Proset? Sorry, I thought you weren't hearing me. So I guess one example where I can dive into is a Horizon project that we're participating in. This project is multidisciplinary. I'm glad I heard Malcolm mentioning it in his opening speech. We need to work with different professions. The projects coming in from Europe insist that you have different partners, and we have partners from all over Europe on this. I'll just explain quickly what it's all about. No details, I'm not a scientist. What is happening, what we're doing is a functional placenta on a chip. So it's, and the idea here is that we test the placenta to see how much medicine or even toxins are absorbed by the fetus. So there's a lot of technology going on. 3D bioprinting is one of them, obviously, printing the cells. Huge challenge. This is functional, so it has to be alive. So there are the fluids, the microfluidics, which is the maternal side, and the microfluidics, which is the fetal side. And we see that the transfer of medicine across the placenta into the fetal side. So this is all microfluidics. It's 3D bioprinting at a very small scale. Nanotechnology to get the sensors, because you can't siphon off to test every once in a while. There has to be sensors all the time present there. And we're now adding over and above on it is AI to capture the data, interpolate and extrapolate what's happening there, and even apply it to new medicines that could come out. We all know it's difficult to test medicines. It's much difficult. You cannot test medicines on pregnant women. This is an area that is really important for people to come together. But interesting enough, it's not just the sciences. We are really concerned, part of my responsibility, to see that the TRL level, the technology readiness level, is high enough for that to be commercialized. And this is not easy, because obviously we're talking about the complex system of clinical trials and accepting things going in. Clinical trials have parts of it that can be automated. I'd like to think that sometime in the future we won't need to test medicine on humans, but maybe we could just put it into a black box, and that comes out as a result, yes or no. The people at Medicines Authorities don't think that's going to happen anytime soon. But this is, I guess, when you have an idea and a vision where we can take this forward. So this is an example of a number of them being brought together. But the important part really is policies, regulations, how will this fit in, and how it can be used for different medicines, existing medicines, new medicines. The new medicines have a strong input of AI nowadays. Almost 80% of those being presented for approvals have a strong AI history in them. So that is being used now. But this is a quick, because as a panel, I don't think I need to.
Thank you, Engineer Sammut, for those insights. Moving from potential to current realities. Prof. Jean Kaleajus, what would you say are the most promising innovations in healthcare today, and what key obstacles must we overcome to realize their full potential?
So first of all, thank you for the invitation. It's an honor. So the innovative aspects are many, and as Joe just said, I mean, the multidisciplinarity aspect is very, very important. But just to take three things, I mean, which are also at heart apart from the placenta on a chip, I would say that three issues which also on a Maltese level are, I think, very relevant are, first of all, management of obesity. I think obesity management, I mean, whether it is through injectables or whether it is through bariatric surgery, I think currently we are in a situation, not just for Malta, but for most developed countries and developing countries, I would say, where the supply is not meeting demand. So there is a lot of work which needs to be done, both from the medical, but even from the engineering and the innovation point of view in that aspect. So that's obesity. Another aspect is the medical waste management. So when I'm talking of medical waste, so I'm not referring to tissues, but I'm referring to the drapes, to the gowns, to some instruments which are not, they can't be reused. And of course, I mean, that also is very important because hospitals and medical procedures do generate a lot of waste. So of course, because of the nature of the operations. And of course, disposing of that waste, but not just disposing, but actually recycling that waste. So we are currently looking into collaborations, even for example with TU Delft and the Netherlands, where we are trying to look into how to recycle drapes and gowns into products which are actually feedback into the surgery industry, like for example, converting them into handles for your medical instrumentation, for example, okay? So that would be the second, and then I think the third aspect is data. So in fact that I will tie in then when it comes to the personalized medicine. And data, I'm referring to two current, not projects, but initiatives which are being taken on a EU level, which is the European Health Data Space and the Genomic Innovation, I made a note, Genomic Data Initiative. And these two are working, of course, I mean, in trying to create this data space where all data, of course, being anonymized and still respecting data privacy, but all data, including health data, is fed into this data space so that, of course, I mean, it can be then used for personalized medicine. But I think I will touch that when it comes to the next question on personalized medicine.
Okay, so let's move on to it now.
Okay.
Personalized medicine promises to tailor treatment to individual needs. Could you elaborate further on how this approach could transform the diagnosis and treatment of diseases and the main challenges in achieving this?
Okay, so basically, so when we talk of personalized medicine, you can take it on two levels. So you've got the medical treatment, like you have a patient with, let's say, a particular cancer, and this particular cancer, I mean, as you all know, I mean, not one cancer is similar to another. I mean, even if you're talking of, let's say, breast cancer, but two patients with the same type of cancer they can have different mutations, and of course that will affect their response to that particular treatment. But also when it comes to personalized medical devices. Okay, so that is also, of course, where the innovative aspect is very important. So let's start first with the medical treatment, all right, targeting medical conditions. So if you're looking at targeting medical conditions, of course, you need to have information and you need to have speed in order to, of course, be able to have the knowledge on how to make a diagnosis and the specific diagnosis, which is personalized for that patient. I'm using the example of cancer just because probably at the moment the EU, through its mission for its fight against cancer, like the Beat the Cancer plan, there's a lot of money being invested in that area. And even on a local level, I mean, you must have heard in the news last week, also there was the Cancer Hub, which has been launched. So there's a lot of interest in cancer. Of course, also cancer is on the rise, like, 1 in 3 people in their life, I mean, will unfortunately be diagnosed with some kind of cancer. So it is, yes, very relevant. Of course, in that case, you need to have information which is accessible and which is also replicable. And that is when it feeds in then into this, for example, genomic initiative. Okay, because you don't need to replicate, you could have a database that you can access, and if you find a particular mutation, for example, then you can have your database which tells you which treatment would be applicable. Now, the challenge with that, of course, is that if you take a country like Malta, but any other health institution, any other country with a health institution, that will, of course, increase the demand on the health system. So on an already stretched health system, you're increasing the demand. Therefore, that would require, one challenge is having innovative procurement ways where, for example, I mean, you could have manufacturers of certain medicine that they offer also diagnostics. So, and by diagnostics, you could have genetic diagnostics, you could have automation to speed up and make, of course, your diagnosis cheaper and quicker and more specific, right? And more reliable because you have automation and more specific and sensitive. Of course, that would mean then, yes, like even the need to have multidisciplinarity, because you don't have just your medics, your engineers, but even who's going to provide the treatment, okay, like the procurement. So that is where it comes to medicine, to genetics. Where it comes to wearables, I would like to use the example of the insulin pump, which I think has revolutionized treatment of diabetes, particularly in children and young people, where you have a situation where, for example, it's very difficult to monitor your glucose levels, but of course, I mean, if it's not monitored, the effects are very severe. But with the use of these insulin pumps, which are, wearables, these innovative wearables, that has, adapted and made the patient much more confident, with their treatment. Now, in a similar way, you could have devices for other medical conditions. So the same success story could be personalized, could be used for personalized wearables for other conditions. Of course, there is then also the field of non-contactless monitoring. And here, I mean, I can talk about a project that we are doing between our faculty and Professor Kenneth Camilleri and Professor Owen Falzon. I'm not sure if they are here. Yes. About non-contactless vital signs monitoring, which is also a very important field that especially has been highlighted during the COVID pandemic, where, of course, having ECGs and other equipment attached to a patient, of course, apart from reducing mobility, etc., I mean, there is increased risk of infection, and also trying to decrease the need of hospitalization, because if you can have monitoring of patients at their own home, or reducing the need of admission is, of course, very important. All right, and finally, the last thing I want to touch upon, because I don't want to take over this panel, is using personalized wearables, not just to deliver treatment, but even to deliver advice. So, of course, most of us all have a smartwatch which tells us how many paces we've done in a day, or how many carbs we should eat. And thank you so much. Thank you. And having those type of wearables which give you advice and medical advice is, I think, very much taken up. I mean, already we find a lot of those apps available.
Thank you very
So
much,
thank you.
Professor, for those insights. Miss Celia Falzon, let's expand our horizon to future possibilities. How do you foresee the future of healthcare delivery evolving, particularly with the integration of technologies like VR and wearable devices?
I think I will touch upon what the professor was saying. So what we really would like to achieve with technology in the future is to avoid the patient having to come to the hospital as much as possible. And the first thing to do is to, first of all, help the population manage its own care. And this is another point I think we will touch upon later on. So the more information the patient has at their fingertips or on their arm or whatever about the condition that they have, and the better they are able to manage it, then the better our healthcare system can support them. Clearly, with technologies like VR and AR, we can go a step further because we can demonstrate eventually in the future to the patient what is actually happening to their body. And my dream would be that the population would start to understand how certain lifestyles and certain behaviors have a physical impact on their body, which perhaps they cannot yet feel, but which we can demonstrate to them using virtual reality and augmented reality. So that we might be able to, in the future, how shall I put it, adjust their behaviors before they really start harming their body. Because what we do today, all of us, so I'm a coffee addict and it's no good for me, and many of us do things that we know we shouldn't do, but until you really feel the effects and until it's really hurting you, you don't change your behaviors. But if you can visualize your own body and you can be shown what's happening to your own body before you can even feel it, then perhaps we can start to modify our behaviors. So I think that is how innovation can really, really help us.
So as they say, prevention is better than care, right?
I will always stress on that because my dream is that we will have no patients and we can all live a very easy life. So as we know that the bulk of the conditions that we handle today in developed countries are preventable. So the chronic conditions, most of them are preventable. Then there are some conditions where, again, and we can talk about technology helping us in cancer, which is not something that, well, sometimes it is preventable again as well. And even there, our lifestyles impact the propensity for us to have cancer. So I think that is where technology can really, really, really take us to the next level.
Thank you very much. Exploring the local impact, Dr. Tatiana Kirkop, how can the impact research conducted right here in Malta be leveraged to enhance our healthcare systems?
Not okay? All right. Thank you. So for the healthcare systems, we must remember that healthcare systems are so varied in their nature. Engineering is also very varied in its nature. So combining the two together is a very, very interesting challenge. Impact research is a particular kind of research which targets impacting the lifestyle, impacting society, impacting our communities and the individual. So it is very important that our research has always that at the background. Coming from MCAST, of course, we're always targeting impact research and applied research, so it is home to us. I'm not saying that other kinds of research are not relevant, of course they are, but in these cases, if we want really to leverage healthcare, we need to really target the needs that there are in the communities. So the first thing would be, we really have to identify the needs and have the ways of going about that. We really have to have the community on board, the community as in society at large and the employees, the healthcare professionals themselves. Apart from that, when we talk of leveraging the impact research, we also need to keep in mind that we need to have researchers on board, meaning that as a nation, we need to have a number of professional researchers, meaning also that we need to have training courses, particularly on research. We already have those, but we need to strengthen the research profession, the research management profession. So the employment side and the training side. And these need to grow in parallel over the next few years. Of course, for a supply and demand coordination. Also, apart from identifying the needs, then we need to incentivize the researchers to make sure that we go to the next step. Not just stop at the research, but then going to the commercial side to really make the impact on the society. And also the social innovation side, that's another point that I wanted to make. Changing the mindset of our society. Maybe elderly people aren't so willing to, trust the digital side with their own health. Okay? But we need to start sowing that seed. We need to start encouraging people to trust the healthcare system, because if the healthcare system is trusting the digital side, then we need to trust it as well. And that will make a big difference, I think, what was mentioned before, for independent living, our elderly community having the independent living that we were talking about, and therefore changing the mindset even from a young age so that over the years, over the decades, we'll get there.
Thank you. Building on local advancements, Ms. Falzon, how can we foster a culture of innovation within healthcare organizations and encourage collaboration among stakeholders?
Well, frankly, in my experience, the clinicians are very keen on innovation. So I have to say this because it's not usual, but I think it's true. So they like to do research, they like to participate in research, they like to attend conferences, they travel a lot, they see what the latest technology is, and then they come banging, wanting the latest toy. And it won't be a toy very often, it will be true innovative technology, which we actually use. And at Mater Dei, I can mention an infinite number of projects where we are going for the very latest technology. I can mention, for example, the MR-Linac, which is a linear accelerator, which is guided by MRI and which allows the clinician to target the tumor directly in real time, seeing where the radiation is being applied and ensuring that the radiation is only applied to the tumor. Today, first they take the image and then they apply radiation, so the accuracy is not what it will be once we have this machine, which is operating, and hopefully in a few weeks' time. I can talk about digital pathology. So today, clinicians take a sliver of tissue. When they take a biopsy, they put it on a slide, they put it under a microscope, and the pathologist will analyze it under a microscope. With digital pathology, another project that we have on board is that slide, and a digital image will be taken of that slide, which can be then enhanced and enlarged, and various people can see the same image together, so collaboratively in a multidisciplinary forum, and you can even share the information with experts abroad, so on and so forth. So the changes are really, really significant. Just now we've had approval for up to 4 IT projects, which are all driven by AI in the cardiology sector, with a view to supporting the clinicians' decisions, but also to enabling the monitoring of patients remotely using AI, and therefore delivering information to our clinical teams to enable a better response. So innovation at that level happens. where we hit a brick wall, or maybe not a brick wall, but difficulties, is when we're trying to apply changes to practices across the entire hospital. So I will speak about the hospital because that's where I'm knowledgeable, what I'm knowledgeable about. So for example, if we're trying to roll out electronic prescribing, which has been available in other countries for ages, it is very challenging because we have to change the practices of the entire hospital. And part of the solution, in my opinion, is that we need to have change management teams that are dedicated exclusively to those projects. So we're not talking about innovation here, we're talking about catching up with reality. But that is where we find it really hard. Same applies for shifting from our patient files to medical records, electronic medical records. So again, shifting the practices of the entire hospital is a very complex endeavor. And in my opinion, I think we need to have dedicated multidisciplinary teams whose sole objective is to apply to make the project happen. Because the challenge we face today is that we try to use our own resources, who are either clinicians or administrators, whatever they are, but they have other jobs to do. So the change process is a layer on top of an already existing job. And therefore, we do not dedicate the effort and the energy and the time it takes to make these changes happen. They will happen over time, but they take far longer than perhaps they could. And then the other challenge is involving external stakeholders, including the unions, to come on board with practical changes and absorbing these new technology. They're not even new. I mean, these are the IT systems are old technology now, although today we have a layer which is new, which is the AI, RFID, et cetera, et cetera. So those are the challenges that I see.
So following on from what you've said, as technology races forward, Dr. Engineer Anton Bartolo, how can engineers and healthcare providers collaborate to smoothly integrate these innovations into existing systems here in Malta? What are the primary challenges?
Okay, we're at a conference where we're discussing engineers and healthcare providers working together. And we saw some very interesting projects this morning, which we saw involved multidisciplinary teams, transdisciplinary teams. We saw a lot of that. I think this is still, though, one of the challenges we have in Malta, managing to work together to collaborate on these projects. Celia knows how difficult it has been over the past years for university and hospital to work together. Ideally, we want hospital to be a university hospital where research conducted in hospital is the same as research at the university. We're very far from that, unfortunately. And I think this is something which we can address, and it's really a change of mentality, really. We tend to have a mentality of yes, but. So, yes, we can do it, but there is a problem which stops us. We should move from that to a no, but. Okay, so there is a problem, but we can solve it by doing this. Really, it's, I think, up to all of us to change the mindset and encourage this increase in collaboration. So that's one of the problems. Another, the obvious problem is always resources. We say there's a lack of resources, a lack of funding for research. I think what I can add to that is maybe, again, we need to change a bit the mindset here. So we've seen funding for research increase, but very often we are funding ideas. We are funding projects. So a project has a start and an end. We try to say, okay, give us at least 3 years so that we can hire a PhD student, because if you give us 2 years, we can't even get a PhD student. But I think we need to start thinking longer term. We need to start thinking 10, 20 years, and we need to start thinking about programs, not projects. We need to start employing our researchers for longer, so that they don't go from 1 3-year stunt to the next. sometimes they don't get the funding, they have to find a job, they have to see. They try to get a loan, they can't because they're on 3-year stunts. So I think all of this needs to happen for us to make the next step and move forward and start having maybe more dedicated programs and more results.
Addressing another critical aspect of innovation, Dr. Bartolo, could you discuss the ethical concerns that arise with advanced technologies like AI and robotics, and how we can collaboratively address these issues?
So I think actually ethics is something which I think we are quite advanced on addressing in Malta. For example, at the university recently we had a revamp of the way that our research is approved ethically. We moved from a centralized system to having the faculty research ethic committees. From the feedback I get, they seem to be working well, and I think we are moving in the right direction. I mean, even the fact that we moved to faculty at faculty level, I think in ethics, one of the important things is to understand the technology behind what you are approving. So in medicine, it's one thing. I mean, you need to look at patients, you need to look at patient data, you need to look at making sure you're not damaging, doing anything bad. In ICT, it's different because you're looking at AI, you're looking at all the projects. So I think the fact that we've moved ethics into the areas of specialization is a good thing. What I think we need to be very careful, and this is, I think, another pain that we have that we need to overcome, is the added bureaucracy that all these things, so ethics, data protection, all of these, they're all important aspects, but we should be careful not to go overboard and ignore the ethics and data protection, etc., but not to go overboard with the admin and the excessive work we are putting our researchers and people involved in trying to do their research. So let us, again, try to be proactive in ensuring that we're taking care of ethics, taking care of all of this, without adding more administrative burden, more bureaucracy to what is already a very, very bureaucracy-heavy system that we have.
Thank you. Looking at sustainability, Engineer Sammut, how can engineers contribute to creating more sustainable healthcare solutions? And are there specific innovations that could significantly reduce the environmental impact of healthcare operations?
Thanks, Ingrid. If I could get back to the question, but before then, we have formed a Malta Innovation Forum. So, and we have engineers there, but we have non-engineers as well, because we don't think innovation is, particular to one profession. Obviously, it after all is an economics term, not even an engineering term. The idea of us to be more innovative as an island, as a nation, the conversation goes from anything on HR to finance, to policies, so it is pretty wide and pretty varied. And our discussion there goes beyond just sitting down and talking. We intend to pick up information and see how we can address, as we engineers do, so okay, this is the problem, these are the constraints, and this is the solution we're proposing, and see how we can implement it. And obviously what we learn now is that you can't do one thing on your own. You need to, this multidisciplinary, even at the level of helping us improve our innovation track record. If you look at the European Innovation Scoreboard or whatever scoring, we do score low, and there are areas that we can improve. If I could just pick up on a couple, which are the HR, we mentioned the importance of change and having people really almost trained in change. And we are now seeing We had an event a few weeks ago, Enterprise Innovation, as Malta Innovation Forum, with Malta Enterprise, obviously, and EEN. You know, the upcoming innovation manager. Do we have an innovation manager? Do we have an innovation officer? Do we have someone who is responsible for change? Someone who will pick up in meetings what is going on, say, okay, this is what we need to do, but that is different. Because it is different. I come from some time ago now on manufacturing and quality, or quality, you know, as always was, you know, this is how you should do it. This is, don't vary, don't change, don't change to make a good quality product. Is that now change? Do we need to change to make a good quality product? So this is, and there is, I'm sure some of you know, an ISO 56000 now out on innovation management. And this is where I think we need to start learning and understanding how change can happen, has to happen, and how difficult it is, and you need to involve all the people around. And a good point we mentioned, even people outside the organization. Open innovation is another subject we do discuss. I think companies, for sure, you can go online and you can see so many examples of people getting innovation coming in. You know, even case studies like Siri and whatever. These are all technologies that were existing outside Apple, and Apple bought them in. And Google Maps existed outside Google, and it was bought in. This also ties in with the Malta Enterprise had sort of our effort on startups and getting technology to get into a technology readiness level that you can start it up, and you do find funding for this, and we heard MCST mentioning some of those this morning. But if it's done in conjunction with a big company, I think that's really important. We have started hearing terms like corporate venture capital. Corporate venture capital is a large corporation says, all right, I'm putting aside an amount to help small companies start up. And we see the locals are doing it. So you have, you know, I won't mention names, but companies who've set up ventures, Shahaja Ventures. Those are, all right, daily IT companies to suit their own needs. Fine, but it's still encouraging startups, and new technologies can come in. So really and truly, this open innovation, we are encouraging it. There is, in health, we had an event back in February, and we had a Welsh delegation over. It is challenging. We have not mentioned, maybe the subject is a bit sensitive today, but definitely enough public health and private health. We're talking about a lot of data being captured and shared and analyzed, but is this public data or public health data, or is it private health data? There's so much to discuss, so much workshops we can sit down and go through it. And if I could conclude, I'll pick up the term we mentioned here, social innovation. I learned of this over the past few years. We need to be aware. As engineers now, it's not just getting from A to B in the shortest possible time and the most efficient way. But if along the way you are doing a negative impact on society, on the environment, suddenly that is not acceptable solution, even if it's the cheapest, even if it's, because there are repercussions, and we need to sit down and not design solutions on our own, but sit down and design solutions with the stakeholders, including the community, not just the market, but even the community.
Thank you. Ms. Falzon, can you provide examples of how engineering innovations have already transformed healthcare practices and improved patient outcomes?
Before I delve into your question, I just wanted to say something before I forget. So, first of all, I'm really, really happy that the engineering chamber is here discussing healthcare. Because when we talk about healthcare, people talk about doctors and nurses. And they forget that if we're talking about a hospital, without engineers, we would do nothing. So the hospital runs firstly on the engineers. I have to say, without waste management, without porters, without cleaners, we still wouldn't do anything. But the engineering profession for the hospital is absolutely critical. And if you were reading the papers about nearly a year ago, when the lights went out in Mater Dei for a few minutes, it was no joke. And it was only the engineers that put them back on. No doctor put the lights back on. So I'm very glad that the engineers are discussing this sector. And I would encourage you to encourage your young engineers to join our field. It is a wonderful field. It is really, really wonderful. And the work of our biomedical team, engineering team, and the work of our M&E engineering team, right? With our chillers and our boilers and our, I'm not an engineer myself, but we're going to be building a new distribution center. The hospital runs on engineering first and foremost, from medical devices, the small ones, the IV pumps and so on, to the big gadgetry, to medical gases supply. This is all done by engineering, including waste management, which is a big, big effort in the hospital. So I'll move on to the question. So some real examples of innovation. Well, in the past 2 years, we've rolled out robotic surgery. So now you can see our surgeons sitting behind the console, wielding, what are they called? Joysticks with a screen in front of them, and to their side, there is the robot with these little, about 4 sort of robotic arms that are inside the patient, doing what the surgeon is telling the robot to do. But the robot will even stop on its own if the instruction is not correct. So the robot has an element of its own mind coupled with that of the surgeon. I've been there, I've seen it, and it's incredible. And they reach areas in the body where previously they used to operate blindly on the basis of field. Now they have a full visual field. It's truly, truly amazing. We are rolling out surgery where if you have certain cancers, the clinician can implant a seed, a radioactive seed, inside your body directly on the tumor. So it's really precision bombing now. Really on the tumor, we can monitor the patient. Sometimes the patient will have to stay in the hospital and be isolated because they could be radioactive, but the results are phenomenal. I mentioned the MR-Linac, which will come on stream very shortly. I mentioned digital pathology. I'm mentioning we are using AI already in interpreting medical imaging. So many innovations. The challenge, as I say again, is to roll out the changes in practices, the innovative practices which go across the board and which, as Joe was saying, in my view, require us to have teams of change agents who are absolutely trained and dedicated to achieve the desired outcomes.
Thank you. Dr. Kirkhope, as we think about future breakthroughs, how can interdisciplinary collaboration among engineers, healthcare professionals, and researchers be enhanced? What structures or policies are necessary?
Okay, so basically, when we talk of collaboration, we need to remember that we're talking about a patient. It should all be patient-centered. So all the services, the admin, the nursing, the doctors, whatever, the environment of a hospital, the environment of a residential home, whatever, it's all going around the patient's needs. So there needs to be extensive collaboration between all the sectors so that the patient's experience is an excellent one. That is, I think, what we really need to focus on. Now, for interdisciplinarity, in Malta, unfortunately, this is my personal opinion, we do have sometimes, you know, the habit of working in silos, okay? So I think we need to move out of that. We need to push our boundaries. We need to really change the mindset, share data, share knowledge, and get together. We need to start from a young age. So even at primary schools, at secondary schools, at the college, for example, we give tasks to students from our different institutes. We put them in a group. They don't even know each other. One is from creative arts, one is from engineering, one is from business, and we give them a task. So they need to get to know each other, they need to know the strengths, they need to know the weaknesses. And if it's whatever task, the person from creative arts is looking at the aesthetics, the engineering student is looking at the technical side, the business one is looking at the marketing, etc. And in the beginning, they really grumble about this because it is a challenge. But at the end of it, when they pitch their result, then they realize that it is useful. Does it always work? No. Sometimes the team doesn't work. But taking that now into the workplace, we need to do this. We need to, sometimes it's just a chat over a coffee with somebody and something sparks and a beautiful project starts, But we need to have policies and strategies that will enable us to have the structures for this. So workshops between engineering and healthcare professionals, for example, that really put people on a table, not talking up there, but really a task, like we do in hackathons, for example. The industry gives a challenge, you need to solve that. And then sometimes it, grows, sometimes it doesn't. But the strategies and the visions that we need to have to be to collaborate together. We're a small island, we're a European nation, we're a European state, so we need to follow the targets of the European Commission, but also, as a small island, we need to really work together. There's no place for, me and you, it's us.
Thank you very much. I have one final question that I would like to ask all of you, and after that I will open the floor for the audience. So one final question, a short comment from all of you. Looking forward, how can Malta position itself as a leader in this healthcare arena?
Hello. Well, I'll repeat what I said before. Longer view on research, longer term research, funding research programs that really matter for Malta.
From my end, we need to really target working together. We need to really target joining forces and thinking of strategies that start changing the mindset of our society. One, to work together. Two, to be more innovative, to push the boundaries. And three, to also work on funding and strategies and programs that will join the engineering and the healthcare professions in a structured way.
I myself, I'm very optimistic because Malta, being small, small is still good because you've got a centralized health system, because although we do have private healthcare, but ultimately most of the medical and all the teams, they still, also collaborate very well with hospital. We've got a long history of registries, medical registries, which date back, over 20 years. And although the electronic medical records, are still, okay, of course you get people to latch on to them, but I think since Mater Dei opened in 2007, we've got a centralized system where you've got all the lab results, all the imaging, which is all centralized. So I think, and also the fact that you've got a relatively captive population, where you don't really lose patients for follow-up. So we've got studies going back even 15, 20 years. So that's also very good. And the fact that the working language is English. So if you're trying to conduct a clinical trial, for example, using a particular innovative instrument, you don't have to waste money on translation because it's already, all the medical records are in English. So I think we are really, starting, of course, always room for improvement. And I really liked your phrase, Anton, that it's not a yes, but it is a no, but. And I think my personal experience working with the engineers has been a very positive one. And looking forward to more collaboration.
What can you add after that, Tayyip? But if I could make a statement, it's building on our strengths. For sure, what we've seen this morning in the presentations, we have so many strengths. And I think we need to recognize the strengths that we have, and we need to collaborate, share, not duplicate. You know, there are so many things, and help people, you know, achieve more from moving from research, as Anton is saying, but we have to see that where it is put into the market. You know, I used to be at MCST for a few years when I put together the Fusion program. 2013, 2012, Harjet was 2015. The researchers sometimes come in and say, Joe, kellimniex fuq commercialization, I just want to do research. And it is a bit of a pity, but then you see where the team comes in, where the other entrepreneurs come together and help out, because it is a big job doing the research. Let's not forget that. So someone else comes in and collaborates. I think that will help us see the research that is happening, find, you know, climb up the TRL levels and get it commercialized and funded. We offer, as with my multi-enterprise head now, we offer a lot of services. This is the soft infrastructure, not the hard infrastructure. Hard infrastructure would be the Life Sciences Park building. The soft infrastructure is where we help, we network, we collaborate, we do workshops. We have technology databases. Someone needs something, we can go on the EEN database. I have some leaflets on table 19. And you can be on that database and you can sell your technology, not only locally but abroad. There are so much things to do. So we need to collaborate and network on this.
Well, I certainly agree with all that's been said before. I was testament to what Malta can do when everybody comes together. That was COVID. In COVID, we literally shone. Everybody came together. University helped us. The Homes for the Elderly worked with us. Institutions, everybody supported us. And we achieved a lot as a nation, clearly. So when we do come together and we work together, and it's true that we don't, so we need to find ways, and sometimes it can be technology itself that helps us to communicate better and to come together in more structured ways to overcome the silo mentality, because that is true that we have a silo mentality. Sometimes it's also driven by the fact that I'm very busy doing what I do and anything else is seen to be, too much extra, maybe, as you were saying. And sometimes it's because we don't have the skill set, so as you were sort of indicating, perhaps you can find the other person who's got the skill set to make the project happen. But I will still go back to saying the real change agent would be when we can educate our children at an early stage to really, really look after their health properly as they go along with the aid of technology to monitor their health eventually and to look after it so that we minimize the burden on the health system and we have enough resources then to tackle the obviously healthcare issues that will certainly arise in any event, whatever we do. But that would be where Malta can really, in my view, I would love to see us position ourselves to say the next generation or the generation after that are going to be healthier than what we are. Thank you.
Thank you. We'll try to take one question. Any questions from the audience? Okay, so in that case, and also because our time is up, I would like... Okay, we have a question.
Thank you. I'm Sandra Buttigieg. I'm a professor of health systems management and leadership at the University of Malta and a consultant in public health at Mater Dei Hospital. I'm also here as president of the European Health Management Association with an office in Brussels. Basically, I really enjoyed listening to the panel discussion, and two things that come to mind with the transdisciplinarity that has been very well discussed on the panel, in particular the engineering with the professions coming from healthcare. Maybe we can think of adopting more systems thinking approach rather than firefighting, crisis management. And it is the engineering profession that can help us to achieve this. by having an integrated healthcare system, meaning not focusing just on hospitals, but taking the entire health system using seamless technology, analytics, telehealth, and getting rather than just patient-centered, person-centered care, which means we are empowering patients to take care of their health. And one thing that is developing very much in view of the overcrowding of the hospitals and healthcare clinics is informal care. And informal care is none other by the carers, relatives of patients, of persons who need care in their homes. And this can be done using technology. In 2023, The Economist wrote an editorial going for virtual hospitals. And virtual hospitals are none other than reducing the administrative load on the hospitals, going green and digital across the entire health system, and using analytics and remote technology where there can be a seamless technology across the stakeholders, but not forgetting the patients as persons and users of healthcare to contribute. I believe that that is the solution for the future in terms of sustainability and resilience of our health systems. We, healthcare professionals, need you, engineering professions, to help us in achieving this. Thank you.
Thank you very much for your very valid comments. Because time is up, I would like to thank all the panelists for a very fascinating discussion. It's clear that the road ahead is full of challenges, but also immense opportunities. Thank you.
Thank you once again to the panelists. Thanks for the nice comments and remarks on the achievements of engineers in Malta. It does miracles to our ego. Thank you also to Dr. Ingrid Gallia for guiding this very insightful discussion. This leads us to the second session of this conference, a more practical overview of engineering in healthcare, with the theme Technology and Medical Facilities. Kicking off the discussion, allow me to introduce our next keynote speaker, Dr. Jagat, the CEO at EBO.ai, who aims to uncover the future of health engineering, exploring how AI is not just shaping, but is fundamentally sustaining the future of critical industries, driving innovation and efficiency across sectors. Please, a warm welcome to Dr. Jagat.
All right, hi, good afternoon. It's really lovely to be here amongst so many engineers. I'd like to start immediately with a show of hands. I believe that AI isn't just coming, it's already here. And a show of hands to who's used AI this morning. Who used Google Maps to get here, or perhaps Spotify? Hands up, please. About 2/3 of the room. So it's clear that we are already using the technology which we are going to be speaking about in this session. And to my team at the back, speaker notes are not up on the left.
Research indicates that 1 in 4 Britons feel that the NHS does not care for them at all. But the good news is that when we look into patient data, which I'm marking with a red box, we see that most of the issues do not stem from poor clinical activity, but actually stem from the inability to re-engineer that touch point where patients interact with the healthcare system. We call that the patient engagement touch point. And that's why we are fortunate as a company to work with 2 of the largest healthcare problems which we see today, which are the problem of access and the problem of demand. As you could see from the pie chart, research shows us that around 1/3 of all adults in the UK and also in Europe do not have the necessary digital skills to interact with healthcare systems. So most patient portals, most interfaces are too complex. So our job, through artificial intelligence, is to lower the bar of digital maturity that is necessary for patients to access the social good of healthcare. Additionally, the second problem which we deal with is demand. The World Health Organization has issued a fantastic study which predicts that by the end of this decade, 2030, we will have 10 million less clinicians than we need in Europe to provide basic primary healthcare. Now, this is a shocking statistic, and we know that there's nothing we could do now to push more students to the educational system to get us to the state of readiness by 2030. And this is why I believe that artificial intelligence is a key enabling technology, because it can help us close the gap of demand, which we are not going to be able to solve merely through additional human activity. This is why EBO is today a leading provider of artificial intelligence at this engagement and automation point. So if you have to look at what we do at a very basic level, we identify clinical pathways whereby the patient can engage in a much more positive and easy experience. And by doing so, we release efficiency, we increase the workforce capacity, and we reduce the operational costs of the business. Obviously, the ultimate goal is to ensure that the citizen gets a much better experience when communicating, when interacting with the hospital. So we have set ourselves a 6-year plan, and we are looking at where we would like healthcare systems to be in 2030. And our vision is this. Those processes which are presently reactive need to become predictive. The hospital should come to you predicting your needs before you actually go to it. That which is inaccessible, often which is due to layers of complexity, needs to become accessible to all, especially those who are marginalized in society, who most need access to public health. That which is depersonalized and makes the patient feel like a number needs to become adapted to the specific needs and profile of that patient. That which is offline, paper-based, and siloed needs to become data-rich. It needs to become contextually aware. Of course, AI is really good at that. And that which is slow, those processes which take too long to unfold, need to be shorter, they need to be real-time, and they need to be on demand and immediate for the patients. That which is complicated, medical forms, which so many patients don't understand, needs to be much simpler. It needs to be conversational. The large move in artificial intelligence is conversational AI, the ability for a machine to understand and generate language. So that which is inconvenient needs to become at your pace. You might need to go through a process over a number of days, not only within the few minutes in which you're sitting in front of a nurse or a different clinician. But that which is in person and burdensome needs to become accessible anywhere. Celia's last point about virtual wards, it's coming, right? So healthcare is not anymore offered by the institution in the brick and mortar building, but is accessible from your home. That which is in one language needs to become multilingual. In England, in the 16 million cohort of patients that we serve, most of the conversational AI is in Polish, is in Farsi, is in German, Spanish, French. Why? Because the interface with the patient needs to be easy for the patient, whilst the data then needs to be normalized back in the patient record system in the language of choice of that particular nation. And finally, that data, which is trapped and siloed into different medical systems, needs to become interoperable. And I think this is a good launchpad for me to share with you some of our projects, experiences, and maybe give you the 4 AI megatrends which I identify in the industry and I see in the healthcare sector across Europe. So the first trend which we need to be aware of is the trend of digitization, or maybe ultra-digitization, where every element of data becomes an important asset to the hospital. And now, through AI, we can process massive amounts of data volumes in a little time. So for those of you who look at pattern recognition, we know today that AI can recognize one face from 50 million faces in less than 1 second. Imagine the advantages that gives to us to find outlier data sets. We know today that AI can process 3,000 engineering academic documents in less than 11 seconds, and from it create new knowledge, right? Usually, this takes a PhD most of the academic lifetime to go through. And here's an example of a project which we ran in Wales, which follows this mega trend of digitization. I won't pronounce the name because it's in Welsh and unpronounceable for me. We'll call it Betsy. So this is a hospital about double the size of Mater Dei. So they serve about 700,000 citizens. They employ around 19,000 staff. Their annual budget is just shy of 2 billion. And we worked with Wales to digitize the entire patient footprint around waiting lists. Those patients who are waiting for hip replacement, knee surgery, and so on. And we did 2 things. Firstly, we created a waiting well environment, which means that whilst the patient is waiting for the operation to occur, a virtual agent is speaking to the patient constantly, giving them help on how they could treat the ailment which they're complaining of until their time is due. At the same time, we are constantly reprioritizing the waiting list based on medical criteria to ensure that those individuals who don't need to be at the top of the waiting list are deprioritized, and those whose medical condition has changed and escalated move forward. The good thing from a process cost point of view is that for every 20,000 patients that we validate in this way, the hospital started saving £137,000 per 20,000 patients in the system, when compared to their traditional methods of call center, phone, send a letter, post, nurses receiving inbound calls. I mean, it entirely changes the profit and loss account of a hospital that is serving 700,000 patients, right? And this is how AI's ability to digitize all the facets of an ailment and a waiting list could increase the process speed. The second mega trend I'd like to speak with you about today is the concept of dematerialization, right? So we are moving from a world in which in the 80s, those of you who have some gray hair like me might remember these devices that we needed to push and touch to actually utilize and make sense of. But today we're living in this world, right? One single portal, which is your phone, to the entire health ecosystem. But this phone, of course, is doing much more than just that. It's the device on which you handle your trading, perhaps your education, maybe even your religious activities like praying or unlocking your door or a wallet. And now, speech is the next big thing. So in the NHS in the UK, we are now introducing the ability for a patient to speak to AI 24/7 with any language, any diction, any speed, and immediately receive back feedback on the particular areas of activity that we are speaking about. And these smartphones, they are so powerful. And often we forget that the smartphone which we have in our pocket now is 1,000 times more capable than the computer we used to land man on the moon in 1969 in the Apollo 11 mission. And now AI is moving out of smartphones into so many physical devices. Of course, autonomous vehicles is the obvious example. I think our kids or the next generation is going to be the last generation that is going to need to take a driving test, because we will move to an environment which has a higher safety record on the streets through AI. And talking about this concept of dematerialization, I'm just going to show quickly a project which we did for NHS Somerset, which is also a significantly large area in the UK, about 3 times the size of Mater Dei. And what we did for them is we automated entirely the appointment management process. So the interface has been dematerialized. Previously, you'd have to walk in, register, go through an assessment, and get a particular appointment set, or you'd call a call center or actually send a physical letter. We have now changed that entirely for around 2 million citizens in the area of Somerset and Taunton, and now that interface is dematerialized. You speak to your phone, you move into a virtual agent 24/7 in any language. And I'm really pleased to see that there's St. James Hospital amongst us today, who also utilize this technology and have a very successful virtual agent. Perhaps Jean will speak about this later, which automates part of the appointment management system within the hospital too. And if you look at some data emerging from Somerset, we see that AI is able to recognize 99% of what the citizen says. If you had to compare that to a teenage call center operator at secondary school or sixth form level, the rate of recognition is usually around 82%, perhaps because they're easily distracted and so on. So today, AI can not simply dematerialize the interface, but become better at understanding human initiatives. And of course, patients are happy with this trend. It's an easier way to access healthcare. The third trend, which I think we all need to focus on, has financial bearing. And it's the idea of demonetization, right? So what we are doing at EBO is we are demonetizing processes which traditional suppliers would offer. Paper-based clinical assessments, call center-based patient waiting list validation. We are entirely demonetizing that industry and moving that healthcare service, which is a multi-step, complex process, into a simple, bi-directional conversation between the patient and AI. Amazon is entirely demonetizing marketplaces. It is the most important modern marketplace, and with its AI predictions, it can determine your needs as a patient, as a citizen, more accurately than most brick and mortar operations. YouTube, of course, is demonetizing the entire content world. So its ability to create content and utilize content from citizens is today the most important sucker of human attention. Nothing consumes more citizen brain time and attention than YouTube today. And of course, the obvious example, ChatGPT and other large language models, is entirely demonetizing certain roles. I think today, junior services such as, junior advertisers, junior lawyers, junior writers, junior tutors, their job is going to be at risk because of the automation capabilities which we have today. But of course, we spoke about drug discovery in the panel just before me. We are also demonetizing the human research which usually goes into drug discovery. It's useful to look at the speed here, right? In 2020, in the States, we had no fully AI-driven drug discovery. By 2022, we had 18 fully AI-driven drug discovery activities now in clinical trial, just in 2 years. Now, you need to understand that the exponential curve of growth is like nothing we've seen. Or perhaps it's like COVID's infectious expansion. That is the exponential curve that we're seeing. And I think that if there's one thing that we need to focus on is that universities will be the hotbed for AI spin-outs, and industry and academia coming together are going to be the secret sauce for Malta's economic development. But if there's one area which AI is demonetizing, it's salaried work. I'd like you to look at this screen, which contains a shot from our Innu Malti, from our national anthem, particularly the lines which are highlighted in yellow, Rotti l-ħnina lis-sit u s-saħħa lil-ħaddiem. I think from the days of Karl Marx, work, employment, salaried work, has become so critical to our political system that we also put it in our Innu Malti. But in a world where around 45% of most tasks can now be fully automated through AI, AI which is at a marginal cost of zero, which doesn't claim any sick leave, which does not canvass for itself, which is not unionized, which does not have parameterized limits. Who is the Haddim that we are protecting? And here there are so many ethical questions that I think we need to ask ourselves. You know, what does fair compensation for humans mean today? How do we build teams that understand that the future of engineering, the future of healthcare is about human and AI collaboration, working together? How do we distribute the wealth that AI contains? How do we regulate for this particular sector? And how do we move our education system to clarify that education, that the future of employability is much less about what you learned at university and much more your ability to change and learn over time? And the fourth trend I'd like to share with you is the principle of democratization. I'd like to lead this with one example. So let's talk about an interesting topic: sexually transmitted diseases, or STDs. Right? So one of the problems that Brexit created for the UK is lack of resources, because most of your principally Greek clinicians left the UK. So because of the lack of resources, in STD clinics, they were unable to match the gender and age of the patient with the gender and age of the clinician. So we started seeing a couple of years ago, post-COVID, these type of realities. So you might have a 60-year-old male clinician who is matched to a 14-year-old female patient who's going in for a first STD assessment. We noticed a huge decline in the use of public health services in STD. Why? Because there was social awkwardness. So the young female patient talking about first sexual experience didn't have another female clinician to speak to, but someone of a different gender, possibly a different ethnicity. So most patients started giving insincere, they were lying about their particular experience, which led to misdiagnosis, with the clinician being unable to provide the right level of medical care. So what we did is we turned this around entirely. So we re-baselined the STD clinic. We introduced an AI-based virtual agent, which would match the gender. It's funny because we think of AI in terms of gender. It would match the gender of the patient. It would ensure anonymity. There is no judgmental element that is going to come from the AI. And if your interaction with the AI is through a chat, it is the most natural thing for a 14-year-old to do, because that's how they spend 90% of their day anyway. So you are culturally attuned to the patient's requirements. The results? We reversed the trend entirely. So the use of STD clinics went up through the roof, and the cost to the state to treat STD declined by around 82%. Because it's one thing catching chlamydia in the first week, it's another thing if it goes unnoticed for 3 years, when it's then a big and costly problem to solve. And as we talk about democratization, let's also realize that we are going to live in a world where everyone is going to be hugely connected. So in a few years' time, we are going to move from 5G to 6G. Expect this by 2028. And 6G is going to change our experience of the internet totally. Just to give you an example of this, you will be able to download 142 hours of Netflix content in just 1 second. So as we conclude, I hope you've realized that my discussion today is not about technology. It's about change, right? It's about how can we act on these mega trends which I'm bringing forward. And my prediction is this: by the end of this decade, there will only be 2 types of companies. Those who understood and fully utilized the capabilities of AI, and those who are essentially out of business. So which category do you want to go into? What actions do we need to take now? Well, my sense is this. If Google and Microsoft and other trillion-dollar companies are moving all in towards artificial intelligence, it is the only thing they are betting on. My sense is that there is no "we are too early" discussion that we should be having here. Right? You need to shift your entire strategy and focus on this new capability. I think you should do so right now, as quickly as possible. And a final thought that I'd like to end with, which is perhaps the most important learning for me. Digital is never about technology. Digital is always about people. It's about culture. So innovation is not just about new ideas, it's about the right ideas at the appropriate time. And in this transformational journey, technology isn't the end, it's the means to the end, right? It is the necessary journey. It's how we stay competitive. And the beauty of AI is that it's always changing with new capabilities. It's endlessly scalable and creative, and today is available at a very, very low cost. I believe the future will not belong to those nations, those states, those companies that wait. I think the future will belong to those who are bold enough to innovate. Thank you. Thank you.
Thank you, Dr. Gatt. Interesting developments in AI. I predict that next year the presenter will be AI-powered. You're out of luck today, sorry. But going forward, as engineers and ultimately as end users, we can certainly appreciate and recognize the importance of having reliable facilities at hospitals. Our next speaker, Dr. Engineer Nicholas Aquilina, an electrical engineer at the Foundation for Medical Services, will now delve into the engineering challenges faced when designing a healthcare facility, as well as the critical infrastructure in hospital. Please let us welcome Dr. Aquilina.
Thank you, and welcome for this presentation about the critical infrastructure in hospitals in general. So to start with, let's identify or let's classify what is or what makes the infrastructure critical, or what's made out of. Basically, critical infrastructure can be broken down to the assets. In our case, in a hospital, is the medical equipment, so all the medical equipment that we've been hearing today about, and also other equipment. The systems that ensure that these equipment can operate, so it's the electrical supply, the HVAC, medical gases, the IT infrastructure, security and access control, and also the building itself, because without it, of course, we'll not have any hospital in the first place. And all of these are important because we need to ensure that a health system will operate safely, efficiently, and consistently. And in fact, when we mention the term critical, of course, the first thing that comes to mind is the electrical supply and the distribution. As it was mentioned in the panel a few minutes ago, we all remember what happened when last summer there was the loss of electricity at the hospital. So, of course, any interruption of electricity can lead to minor inconvenience if it's not a full blackout, let's say, and it can the severance can increase up to loss of life. So that's why it's important that we make sure that the electrical supply and distribution is designed properly. And in fact, we need that the electrical supply has to be both reliable, and we need to design for redundancy. The difference between the two, basically, reliability is the ability for any system to perform consistently as expected, even under varying conditions, while redundancy is the design, or that you design with the intention to have backup components such that the system can take over in case of failure. In our case, when we are designing the electrical supply, reliability is not completely in our hands because, of course, we depend on the utility provider. So it's not something that we can, let's say, improve upon. However, we can design for redundancy. And in fact, there is various things that we take care of. First of all, we design our electrical supply by taking or by incorporating multiple sources, such that if one source fails, we can still use the other source. So if we speak locally, we have sources coming from different substations or from different rings, such that in case of there is a problem on one ring, we can still get supply from another substation. Apart from that, we of course have backup generators in our healthcare facilities in order to power up the load in case of a blackout or a power failure. And usually we distinguish the loads that we have between essential or non-essential loads, and sometimes, as is the case in Mater Dei in our hospital, we have load shedding. So once there is a blackout, there are critical loads or essential loads that need to be powered first. Basically, for example, the ITU, the operating theaters, and then you keep on going down the priority list and powering first the priority areas. And then, as I mentioned as well, we have the critical loads, which in this case, we cannot accept any glitch in the power. So in order to power these, we have UPSs such that at no point in time there will be a dip in the power. And as a last resort, some of the vital equipment that are required to ensure the patient safety, such as the ventilators, for example, they have the built-in batteries, such that in case everything fails, at least you know that you have as well some backup, localized backup, let's say. Another important system in a hospital is the HVAC system. So, of course, the HVAC is responsible to provide a comfortable climate condition of temperature and humidity, although, I mean, to a certain extent, this is not that critical for the patients, let's say, to feel comfortable. I mean, it's nice to have that you are in a nice temperature if you're at the hospital, but it's not critical up to now, let's say. But the HVAC system is responsible for other aspects of the hospital that without it we cannot operate. Mainly, the HVAC system, or especially the ventilation, is responsible to create a germ-free environment in the hospital to ensure well-being of the patients, and as well to prevent the spread of disease. In fact, when we are designing these systems, we have to ensure that the ducting that is used is constructed using antimicrobial treatment to avoid from the spread of diseases. In addition to this, there are medical equipment which are sensitive to temperature and humidity. So if these are not controlled properly, we cannot ensure that these operate to the full. As I said, the ventilation system in particular is important to avoid from spread of disease. And in fact, depending on the use of some specific areas in the hospital, which we'll mention again in the coming slides, we can have rooms with negative pressure or positive pressure. Basically, the idea is that if there is a room where we need to contain all the infections inside that room, because it's an isolation room, for example, it will be a negative pressure. So all that air is contained in that room. And opposite to that, if we have a room which is, we need to keep it clean or sterile as much as possible, we have a positive pressure such that no air from the outside enters the room, basically. Another important system in a hospital and critical system is the medical gases. Something which is not that obvious for people. Medical gases are classified as medicine in a hospital, so it's not as if you have a compressed air system or another gas running around a manufacturing plant. And in fact, in a medical environment, these are managed and controlled by a qualified healthcare professional. Usually it's the pharmacist or the pharmacy department, because they need to certify that the gases are of good quality to be used for human use. Some type of gases that are used in hospitals: oxygen, which is used for life support. Then we have nitrous oxide, which is used in anesthesia. We have the medical air, which is basically the same air that we breathe normally, but that is supplied through the ventilators. We have the surgical air, which is the same type and quality of the medical air, and it's used for medical tools. Maybe in the past more than nowadays, some tools that were used in the operating theaters used to work with the equivalent to compressed air, and the surgical air was used for that reason. And then we have also the Antinox, which is a pain relief, and this is usually mostly used in the labor, in the delivery wards. Whoever had to give birth or be present while giving birth most probably encountered the use of this gas. A medical gas system in a hospital usually consists of two main components. I mean, to describe it briefly, the central source of the medical gas, which is either a bulk tank of storage or high pressure cylinders. And then we have the network of pipes and all the related fittings to distribute the gases to the various areas of the hospital. And of course, all the system, including the medical gases pipeline, have to be compliant with various standards. Moving to another system, the nurse call. Basically, the nurse call system is important because thanks to it, the patients can communicate or can alert the nurses or the nurse station with the needs they need. Basically, or the basic units of a nurse call system are a call button on the wall or on the bedhead unit, and the handset, and in some cases also we find pull cords in bathrooms and restrooms. And as I have mentioned, in case the patient needs help or assistance, he can use the nurse call to get the help of the nurses. And this ensures, or it helps the patient to feel more safe and secure because he knows that help is easy to attain. I mean, instead of having to wait for the nurse to go for a ward round or to walk in the corridor and see what happens to the patients. Apart from this, the nurse call system also offers analytics and reporting. This is very useful because it can record how long it takes, for example, for a nurse to reply to a call. It also reports if the call was answered or not, and this helps as well in the hospital management to improve the operation of the hospital. Apart from that, the nurse call system can also be used by the nurses or doctors itself in case of emergency. Case in point is when there is, for example, a cardiac arrest and they need to call for help, they can use the nurse call by pressing a particular button or a combination of buttons to call for what's called the crash team. Basically, the crash team is a dedicated medical team with special equipment, and they are mobilized quickly and they go to the location quickly to treat cardiac arrest. Apart from the infrastructure that you have mentioned up till now, which are kind of general infrastructure, you find this in all the hospital. There is certain areas where they have dedicated infrastructure which is critical for that particular area only. And some examples of these areas are the operating rooms or theaters, isolation rooms, and also mental health facilities. So if we discuss something about the operating theaters or operating rooms, and we see what are the critical parameters, let's say, related to the HVAC and their quality. In such areas, we have 100% fresh air, because of course we cannot tolerate or risk the contamination of air. In order as well to try and be sustainable, energy recovery can be done, and we use what's called the runaround coil system. This particular system is used because it's a heat recovery system, but it ensures that the air flows are completely separated, and therefore there is no mixing of the exhaust air and the supply air. The fresh air which is being supplied is filtered by making use of HEPA filters. And then, to go back to the introduction, we need redundancy once again, so we have a duty and a standby fan, such that in case of a failure, we still have ventilation taking place. And also the each theater will have a fallback mode, such that the operating theater will always be ready to be used. I mean, in case of emergency, you don't need to wait 15 minutes until the temperature cools down and the air is kind of circulated. I mean, theaters, it's a matter of being used instantly. And as I have mentioned, the theaters are maintained at a positive pressure, such that any infections are avoided or are prohibited from entering inside the room. Another important thing to have in a theater is what's called an isolated power supply. Basically, this is required because in an operating theater, as I have mentioned, there is a lot of electronic devices and electrical tools, and also it can be a potentially wet environment, and therefore this can create a risk of electrical hazards for both the patient and the staff. And therefore, we need to make use of the isolation power system, which basically provides an ungrounded electrical service. This is similar to what maybe in older days, let's say, it was used more often than nowadays. It's the same concept that is used in the shaver unit that we used to find in bathrooms. Nowadays, they are all with batteries, so it's no longer that common to find it installed in bathrooms. And basically, in an isolated power supply system, as I said, it's an ungrounded electrical service, and in case of a single line to ground fault, there is no risk of electrical shock because you are not at the same potential as the rest of the supply. And therefore, it's much safer for the patient and also for the staff, because you don't want to get the staff to also get injured, basically. To go a little bit more in detail, the isolated power supply will consist of an isolation monitor, line isolation monitor, and whenever the single ground fault is detected, this gives an alert, an alarm. And ideally, the surgeon or the staff who noticed that there is this alarm will act and decide what to do what would be the way forward? Basically, let's say, for example, you connect a tool, an electrical tool, to the isolated power supply, and that tool had a fault to ground inside the wiring of the tool, and there is a fault. The isolation monitor will alert you, and there will be no electric shock, so no one will get injured. But and also, since this is isolated, there will be no trip. The electricity will still be there. There is no overcurrent protective devices that will trip still now, and you can still operate. So then it's up to the surgeon to decide if it's something small that he needs to perform quickly and then unplug it and it return to safety. Because otherwise, if there is an additional fault, which can be the case, of course, I mean, you cannot guarantee how many faults you will have and during operation, then there will be a risk of shock in that case. So the isolated power supply will tolerate, let's say, a single ground fault, but then you need to act upon it, otherwise it will be risky. Isolation rooms. So isolation rooms are rooms that are dedicated for patients who have medical conditions or infections that they need to be isolated. I mean, case in point that everyone remembers is the COVID patients a few years ago. And in this case, as I have mentioned, these rooms are maintained at negative pressure, such that all the bacteria and infection is contained in that room. In order for patients to be able to, let's say, live in isolation. Of course, maybe not COVID patients, depending on their level of mobility. You need to have inbuilt bathrooms such that these patients can stay inside the room as much as possible. As I mentioned, this will consist of direct extraction to the outside, and the air is filtered before it's exhausted the outside using HEPA filters. Once again, energy recovery is obtained using the runaround coils because we don't need the air to mix with the supply with the exhaust air. And also, such rooms will be equipped with two-way communication such that the patients can talk with the nurses without the nurses having the need to enter the room. As I mentioned, such rooms can be used from simple infections that the patients are kind of you need to put them in a safe place, up to COVID patients, where of course this staff need to avoid from being in contact with the person. So two-way communication is important, because if the nurse needs to just enter the room to talk with the patient, the nurse has to put on all the protective equipment, protective and personal equipment, which is not an easy task. So it's good that simple communication can happen just between the two without having to entering the room. Moving to mental health facilities, whenever we are designing mental health facilities or refurbishing the existing ones, it's important to make use of anti-ligature devices and products. What are these? These are basically products that are designed to prevent individuals from self-harming themselves by reducing the possibility of using ligatures to inflict self-harm or suicide. And thanks to these products, of course, you can promote or help to have a safe and secure therapeutic environment for the mental health patients. And therefore, the staff can more focus to help the patients rather than to supervise, let's say, the patients from doing anything and inflicting self-harm. And to show some examples of these anti-ligature devices and products, as you can see, the idea of all of these products is to try to minimize the places or edges where people can harm themselves. So if you see the doorknobs, there is no loops or no edges. The light fittings are more robust, such that they cannot remove them. I mean, if it's a normal light fitting which is installed in a soffit, you can pull it and that's it. While that one, it's screwed in place. The wash hand basin, likewise, there is no sanitary fittings which are protruding outside where people can hang themselves with and stuff like that. Hooks, for example, are designed such that when they are loaded with a predefined weight, which is minimal, let's say less than 5 kilos, for example, the hook will collapse. Even the shower heads, they are fixed to the wall, no edges. Of course, there will be no flexible hose as we have for domestic use to avoid ligature, and also the grab bars. So basically, making as much as possible the environment safe for the users. As I have said, we try to ensure that at all times the hospital operation is not hindered. So all the infrastructure that we would design, we try to keep this in mind, that at all time the hospital need to keep on operating, and as I said, it has to do this safely, efficiently, and consistently. And in fact, all the systems and equipments that we require in a hospital has to be in line with the required standards, to be of high quality, and also, most importantly, to be installed to high level of workmanship, because at the end of the day, it's useless having good product, but then it's installed in the wrong way. That's all from my end, and thank you for your attention.
Thank you, Dr. Aquilina. Keeping on the subject of practical operations within healthcare, our next speaker is the operations manager at TechTraco Limited, who aims to discuss the effects of a well-designed patient environment and what solutions TechTraco offers to help healthcare facilities improve patient outcome and well-being. Titled Engineering Solutions for an Improved Patient Environment, please join me in welcoming Engineer Joseph Asha.
Thank you very much. Good afternoon. I'm Joseph, as introduced. I joined TechTraco in 2016 as a projects and sales engineer. And since then, so for the last 8 years, you could say, I've been serving our healthcare clients, which practically covers most of Malta's hospitals, healthcare facilities, even retirement homes, by designing, overseeing installations, commissioning installations in medical gases, nurse call systems, medical supply units, etc. You might notice there's quite some overlap with Dr. Aquilina's presentation. So actually, I'll take the opportunity to focus on some key aspects. There we go. So the title of the presentation is Engineering Solutions for an Improved Patient Environment. So before focusing on the engineering solutions themselves, perhaps it's a good idea to explore what we mean by a patient environment per se. So the patient environment can be summarized that it refers to the physical, social, technological, and psychological surroundings in which a patient is going to receive care. So the physical attributes of a design, the physical attributes of the environment will focus on the architectural layout, the room layout, dimensional requirements, lighting, noise levels. So for example, if a room is well designed, there will be enough space for a wheelchair to access the room and rotate comfortably. A stretcher can come in very quickly next to the bed and allow the transfer of a patient from the bed to the stretcher, taken away to the next treatment. All of these things come into play from an early stage. So that's the physical side. Then there's the social aspect of the surroundings, and this refers to the quality of communication, the way a patient can speak to a healthcare provider or to another patient or to their own families. What systems are in place to allow the patient to be social, in a nutshell. Then there are the technological surroundings, and this refers to the availability of equipment, medical treatments, latest innovations, which we've heard a lot about. The more the patient has access to any of these factors, the better the quality of care they will receive. And finally, there's the psychological surroundings, which you could say is a combination of all the three previous factors. So however it looks, whatever the patient feels, it will have a direct outcome on his well-being, on his or her experience, and finally, on the success of the healthcare facility itself. So why do patient environment solutions matter? First of all, we just mentioned it, it's the patient's well-being. The focus always is the patient's well-being. We do know that a happier patient is typically a healthier patient. We've seen this in a lot of research. And whatever we can do to improve that experience and to give the better care and better quality of care, that will help the patient. Secondly, there's the efficiency. So a good design will imply faster workflows for the staff working in the hospital. And we do know, it's been discussed as well, that staffing is a major issue and that we really need to make the best use of the staff's time. So a good design will imply cost savings, time savings, happier staff, and greater efficiency, okay? And finally, there's safety. So in a hospital, even though we would think that the hospital is the safest place in the world because you can get all the medical care you can get, in reality, there's a lot of risk. There's a lot of movement, a lot of people coming in and out, risk of contamination, medical equipment, which uses electricity, medical gases, we'll be discussing those. So there's compressed gas everywhere in the room, in the walls, in the ceilings. So there is actually an element of risk. And good design will make sure that the patient and the staff remains safe. So at Tektraco, we serve healthcare facilities in a number of ways with a number of solutions. And today I will be focusing on three main ones, which are medical gases, we've heard about those, nurse call systems, we've heard about those, and medical supply units. We also serve different clients in different ways. So for example, we mentioned IPSs as well, but I won't be talking much about those. Gas detection systems, which are linked with gases. But let's focus on these three, because I really feel that these three are the most solutions which impact the patient environment per se. So medical gases, as explained by Dr. Aquilina, they are an indispensable part of healthcare, and they're used in a variety of treatments. I won't go much into those, but let's focus on how medical gases are actually delivered to a hospital. So typically, these are produced by a gas producer, and these are brought to the hospital in the form of a compressed medical gas cylinder. And if you are a small establishment, it might be convenient enough for you to carry a cylinder at the point of use. So if you have a clinic with 2 doctors' rooms, great, you have 1 oxygen cylinder, and you would carry it in a trolley and bring it to the patient to be used. You attach a flow meter, attach a regulator, and you're done. But in a large hospital, so let's say, for example, Mater Dei, you would need thousands of these on wheels being carried around back and forth, and it is obviously a logistical nightmare. Apart from the logistics, you would also have a lot of risks. So the cylinder one, such as the image here, would carry about 7,000 liters of oxygen in the form factor of 40 liters. So you can see the compression of that gas. Which means that it's a very good design, it's a very efficient design, but it will have risks. First and foremost, it's very heavy. And if you drop one of these, you can kiss your tiles goodbye, and you also risk, harming a patient or a staff member. There's the risk of explosive damage. So these cylinders, they have a weak point at the very top, which is the valve itself. So if that breaks, all that energy needs to go somewhere. These cylinders can be pressurized up to 200 bar. In the summer months, it goes even higher. And you practically get a rocket, a very heavy rocket that just blasts through walls, and there are risks there, of course. Finally, if you have a lot of cylinders around, and these cylinders have fittings, and these cylinders have valves, you're going to have leaks, inevitably, and you will get an environment which is oxygen enriched, or if we're not talking about oxygen, if it's something like nitrous oxide, you would get the opposite, you'd get an asphyxiant. So one of our solutions seeks to mitigate these issues by introducing a medical gas pipeline solution, a medical gas pipeline. And the aim of such a system is to provide reliable and safe access to medical gases at the point of use, right next to the patient whenever you need it, without needing to travel around with cylinders. And the aim is to get the right gas at the right place, at the right time, with the right conditioning. So briefly, the main components of a medical gas pipeline system will include a centralized gas source. It can be in a basement, it can be somewhere which is inaccessible to most people. So rather than having cylinders traveling around the establishment, you would have a number of cylinders being kept in a room and manifolds to control the use of these gases. We aim to have, as mentioned, redundancy, so the regulations will stipulate that you have at least 3 sources of supply, and what this means is that you can have 2 modes of failure, and you will still have an automatic source of gases without interruption. So this is great for maintenance, it's great for changing of the cylinder sources themselves, the gas sources themselves, without interrupting the supply, because of course a few seconds of no oxygen could be very problematic. So this gas which is stored yes, apart from cylinders, you also get gases which are produced on site. So we mentioned compressed air, surgical air. Those would be produced with medical grade compressors. And we also consider suction. So suction is a very important gas. It's not really a gas, it's the lack of a gas. But it would fall under the same principle. So suction is used for the clearing of airways, clearing of bodily fluids during interventions. And there is also another form of suction, which is anesthetic gas scavenging. Basically, during surgeries, people are inhaling anesthesia, and they are exhaling it again. And there's a lot of studies on the effects that this would have on the staff, on the surgeons. So during the exhalation from the patient, the anesthesia is in the air, everyone's breathing it, and there were long-term problems identified, and so they developed AGSS, which is suction, which is occurring around the patient, sucking away this anesthesia gases out of the room, where it's filtered and disposed of. So anyway, these generated gases are distributed into a copper network, and they go out to the furthest ends of the hospitals, right at the point where they are used, so next to the patients. So at any point, a nurse or a doctor can just plug a flow meter into the wall. It's like an electrical outlet, really. Plug a flow meter into the wall, and the gas is available immediately. And in fact, part of our job is designing these pipelines to make sure that they are adequately sized, and that every room is adequately equipped with whatever gases you need. And you could either over-design everything and have bores this size, or you can consider the costs. And instead, we run simulations, and we build a model, basically numerically, which would calculate a hospital running at full capacity, and we would say, in this particular room, at the furthest end in the hospital, would you get enough flow and pressure to operate? And you start building your way back to the gas source to identify the optimum pipe dimensions. You also think about longevity, and you also think about a little bit of extra, because as we've seen in most hospitals, for example, during the COVID outbreak, suddenly a ward will double in size, or suddenly they build an extra floor and the same mains are going to be used for double the size of a hospital. So we're always balancing that cost effectiveness with reliability and longevity. Finally, on such a system, you would install alarms and monitoring systems, of course, because you want to detect anomalies immediately. So if you have a loss in pressure in an area, that might mean you have an open flow somewhere. It might mean that you have problems at the gas source. So these will be immediately notified. The alarms are placed in places which are supervised 24/7 as much as possible, so that any anomalies are immediately identified, reported, and we can go in and repair, or the staff can go and repair. So those are the major components of a medical gas pipeline system. You can immediately start to figure out why this is an improvement on the patient environment. The gas is immediately available. You don't need to wait for the cylinders to come to you. The cylinder itself is out of the way, so it's not interrupting any activity. And it ensures that you have a good source of gas, which is extremely necessary at somewhere like an operating theater, for example. So a second solution which Tektrako serves is communication solutions. And this is obviously critical, because you want to give the patient a way to communicate to the healthcare provider as quickly as possible. But you can't dedicate one resource for every patient. So what do you do when you have to have a limited number of resources take care of a large ward of patients? You introduce something like a nurse call system. And the basic nurse call system has existed for quite some time. So the basic principles are: someone presses a button on a wall or a handset or a pull cord, and that call triggers an alarm. It could be audio, it could be visual. You could have a display which shows room 7, patient 1 requires your assistance. And a member of staff will drop whatever they're doing and will travel to the patient to see what's up. So that's the most basic system. Now, this has served its purpose for a long time. It's a really great tool because it serves a purpose. It notifies staff that someone needs attention. But there are obviously many opportunities for improvement. So for example, I'm a staff worker and a light goes on somewhere and there's a sound. What do I do? We're 4 people in the ward. Who's going? Are you going to take care of it? Are you going to take care of it? I'm already serving this patient. Do I stay here? Do I go? But maybe it's more urgent. There's a lot of uncertainty, and this is happening all the time across multiple people. So you need to find a better way to prioritize and maybe start introducing some new technologies. So one of the things that we do offer are more advanced nurse call systems, and we make use of technologies which have been around. They're just being integrated. They're just being integrated into one platform. So touch screens, mobile devices, apps which are linked to these systems, logging, advanced analytics. Fall detection is also quite interesting. So for example, rather than waiting for a patient to press a button to inform the nurse provider that they've fallen to the floor, which is a problem in itself because probably the button is now out of reach, there are devices which introduce sonar and they detect a fall. So this is great for retirement homes. So if you have a person who has just fallen off his chair, this automatically makes a call. And it doesn't make a normal call, it would say fall detected. So the staff member already knows that they probably need help, and it's useless to go alone to see what happened. They will bring another member of staff with them to help the patient back onto the chair or onto the bed from where they have fallen. So such systems, you can see again, it's all about more efficiency and more comfort. The patient will feel like their needs are being met more quickly, more precisely, and they're being truly understood. Even something simple as an incident where a patient spills food on themselves. So they can make a call for a cleaning team directly from the touchscreen, because a touchscreen lets you do whatever you want. You can program as many different buttons as you want, and as many different call levels and priorities as you want. So rather than going through the embarrassment of a nurse coming in, what's happened? I've spilled food on myself. Okay, let me go call a cleaning team. The cleaning team has to come from somewhere else. All of these instances are eliminated, and we get the right attention at the right time as quickly as possible. Okay? So the final service that we sell, let's say, are medical supply units. So a hospital will invariably need a wide variety of services right next to a patient bed. And it's in the form of electricity, the medical gases which we discussed, data, whether it's just for using internet or for the medical equipment itself, and communication systems, etc. All these services need to be made available in beds, at the bed, operating theaters, all types of rooms. Now, one might be tempted to use plastic trunking, which is very attractive in terms of price. It's easy, it's flexible, you can shape it on site. But one thing which you wouldn't know is that these are actually not compliant to European regulations. So whenever you are providing services or storing services to be used by a patient, that classifies as a medical supply unit. And that means that you have to you have to provide something which is compliant to the EN 11197. And there is quite a big document on the requirements, and they do make a lot of sense. So first and foremost, if you're using plastic trunking, you're introducing more flammable materials in a hospital. A bit counterintuitive. Again, a hospital can be somewhere where there is a lot of activity happening, a lot of movement. Stretchers crashing into walls, and beds being lifted abruptly and hitting things, and they have very powerful motors, so you get a lot of crashes and bangs and incidents, and something like plastic trunking might break and fail quite easily, and that exposes medical gases, it exposes electricity. So instead, we opt for something which is much stronger. So there are regulations on the materials to be used, there are regulations on the load-bearing capacity of these devices, the protection around the things which are mounted inside of them. And we do offer these solutions. We design them according to what is needed by the hospital. So for example, on the left, would it be? Yes, on the left, there is a bedhead unit which is more aesthetically designed. It's still compliant, but it's hidden in a feature which looks more like a piece of furniture. Because you do get some hospitals which ask you for a more hotel-like feel, so that patients who are living there for a long time, they feel more comfortable than being in a clinical environment. On the other hand, on the right is a massive medical supply unit, which is used in an operating theater. It's hanging from the ceiling to maximize functionality, and it doesn't interrupt any movement. It's all up there. Everything is available within your hand's reach. And it will offer a wide variety of services as needed. Okay? So all of these solutions, they just have those three aims in mind. So patient comfort, patient well-being, and a good quality of service. Efficiency, so that the workers can work more comfortably, and there is time savings and cost savings. And again, greater safety. So at Tektrako, we focus on good engineering design and practices, and our solutions always have safety, reliability, compliance, longevity, and convenience in mind. So I mentioned a number of times, there are regulations governing all of these devices, all of these solutions. So we do make sure to train our engineers, technicians, installers. We go through rigorous training every year, just to make sure that we can serve our clients in the best way possible. They are happy, we are happy. And yes, and all our engineers, they can act as consultants. We aid clients with writing of SOPs. We aid them in good design and training of their staff, because there's that element as well. And that's it. That sums up my presentation. Thanks for your attention. If you have any questions, thank you. Feel free to ask.
Thank you, Engineer Asha. No feedback is more valuable than first-hand knowledge. So therefore, allow me to introduce Mr. Jean-Claude Muscat, the Director and CEO at St. James Hospital Group, who will share his case study on healthcare with digital tools and AI.
So, good afternoon. Here you show me how to use this. So we're running a bit late, sorry for that. I'll try and be concise. Nispera mux tarawni xi ħobza bajtu bacon palissa. So in 20 minutes we should be having lunch. I'm going to talk to you today about the practical use of AI and digital technology in St. James Hospitals. Before I start, just a little bit about myself. I joined St. James when I was 19 years old. So very young. I had already worked for 2 years selling oil. I got bored, joined the family business. Today I'm 53 years old, and so that gives me 34 years of experience. And I think one constant that we always experienced, one constant challenge that we always experienced in these 34 years was the challenge of having to keep up with technology, which was improving year on year. Every year it changes. You buy a machine, the next year there's a new technology out, so you're immediately outdated. However, I don't know if you agree with me, I feel that in the last 2-3+ years, we're not only seeing an improvement in technology, but we're actually seeing a leap, a platform leap in technology. So it's not just about keeping up with technology now. I think there's a shift. There's a paradigm shift. And with the use of AI and digital health or digital technologies, the way we are seeing and managing healthcare has changed altogether. This is the way I'm seeing it. So I'm not going to run you through the challenges because you know all about them. Jamie is our chatbot. I think this, yeah, okay. Although it's going to be challenging with 2 screens now, but anyway, so we'll see. So this is a virtual agent, which we actually developed with EBO, or EBO developed it and presented it to St. James many years ago, or a few years ago. And today, Jamie handles about 25 to 30% of all St. James bookings. I'll just very briefly give you a demonstration about how it works. There should be some sound.
And you can select through speciality or clinician. Once you choose, you will be guided through the different services or a list of medical professionals offered by St. James Hospital, which makes the process of booking your appointment right at your fingertips. You can book the first available appointment or with a specific clinician, together with your preferred location, after which you are given a number of available slots by date, time, and clinician for your convenience.
Okay, so probably a lot of you are thinking, wow, what's so special about this? But don't see it today. You need to see it. When this was presented to us 5-6 years ago, okay? And I took it to the board, I explained to the board what we're going to be doing, and the feedback was, forget it. People don't want to speak to a robot. People don't want to interact with a machine. I had a doctor who actually told me, this is the beginning of the dehumanization of healthcare. Okay, so this is the way people see and perceive technology. We decided to go ahead. We developed the system. Take-up was predictably slow. Today, the bar chart in red that you're seeing is the Jamie interactions. So the number of bookings which the chatbot, which the virtual agent does. And by the way, we called it Jamie to give it some a human feel. And the blue bar charts are the calls handled and bookings done by our call center agents. Now, what's important here, I mentioned efficiency. In 1 year, so this is 2023, we had 277, almost 100,000 bookings done through our agents, physical replies. Okay, these are people, 30 women, because they're all women, I don't know why, and everyone, all they do from morning till night is answer calls, answer calls, answer calls. Jamie handled last year 1/3 of these, an additional 110,000 almost appointments, okay? So this is very important for us. Why? Because the call center is a very difficult department to manage, to recruit, to work within. You get high turnover, they are lowly paid employees, so it is a very challenging department. So if we look at these statistics today, we realize that Jamie, our chatbot, is probably replacing the equivalent of 6 to 7 full-time call center agents, which is a huge help and an improvement in efficiency for St. James Hospital. I don't know if I'm being heard well. I have to move here. Okay, so that was the first part. There are another 3 related to AI. I will talk to you a little bit about AI in endoscopy. Now, this is something I have to do myself, unfortunately, regularly, with better outcomes. So, I don't know if you guys are familiar with endoscopy. Endoscopy is when the doctor needs to check your insides using a flexible instrument, a flexible endoscope. Now, what is the challenge? The challenge with endoscopy is that you're limited to what the doctor is seeing. With AI, so about 6 months ago, we changed our whole system, and we now have AI-supported endoscopy equipment. What's the difference? The difference is that if you look at the screen on the left and the screen on the right you can see that there's a boat, for example, over here. Now imagine that boat. Imagine that boat was a polyp or a growth or a tumor. In the first screen with our previous systems, and which are the systems which are available in all hospitals at the moment, except ours, you would have missed that polyp, okay? So the AI enables the doctor to have a wider field of view, which is much more comfortable for them to be able to diagnose and to work. Here, you can see an actual polyp. That horrible-looking thing is a polyp. I do colonoscopies regularly because we have a family history of polyps, and polyps normally turn cancerous. So people who have polyps would need to do regular screening so that if polyps are identified, they are removed. Now that is what a polyp looks like. That's what the doctor sees during the endoscopy. AI, so that's easy to see. AI will actually show you, it's a bit like, video games. It creates a square, a green square, around the polyp, and it shows the doctor where where the polyp is. Now, this is an easy one to see, guys. But if you look at this image, now if you look very well, you'll see it. But if you are at the end of your list, 7 p.m., you've done 7 patients before, the chances of a doctor missing this polyp is very high, very high. I've seen endoscopies being done. You see people on the screen looking, trying to check, the nurses. With AI, you don't need to do this anymore. The doctor simply goes into the colon, goes out, and AI will mark where the polyp is. So the doctor stops, focuses on the polyp, puts on white light, and as you can see a polyp there, which would have been very worrying and of great concern in a few years' time to this patient. But the patient has been saved because the doctor removed the polyp there and then. This is an actual, very short video of a surgeon performing a colonoscopy, and you can see the green squares showing the doctor where the potential polyps are. I think it's easy for you to see that it's very easy to miss. You can see the top left-hand corner. I don't know how you would know, how the doctor would have seen that, but okay, so it's quite challenging to see polyps which aren't very obvious in a colonoscopy and an endoscopy. So I think this gives you a good picture of how AI has really helped to improve the diagnostic quality and capability of our endoscopies. The third area that I'd like to show you where we're using AI is in mole mapping. So probably everybody in this room has moles. I used to have a lot of moles, and then I went to Mr. Franz Darmani, and I went on the operating table, and he removed about 20 moles for me. But anyway, melanoma is a very serious condition. So it is the 6th most common cancer, and not easy to diagnose. Many times it's diagnosed late, and that means it might have already spread, leading to dire consequences. What do we have now? We've got what we call a photo finder, this machine is called. The photo finder, basically, here you're seeing a patient. On the left-hand side, you're seeing all the moles. Normally, a doctor, you'd have gone to a doctor, the doctor would have, you know what a dermoscope is? It's like a big magnifying glass. And the doctor checks each and every mole to see whether it is suspicious or not. With the photo finder, I don't know if you can see it on the right, I don't know about the quality of the pictures, but here, the photo finder has created a circle around each mole. Okay, there's a circle around each mole. And beyond that, what it will do in the next step, it will actually identify, and here you can see it better. In the next stage, you will see, it will identify from all those moles, 3 moles which need further attention. Okay, so the patient isn't going to go out full of holes, but the doctor is going to focus only on these 3 suspicious moles. This is what it will eventually look like, so you can magnify and see the length and the depth and so on of the mole, and then that leads the doctor to be able to take the necessary action and intervention. This is another patient, this is a Maltese patient who started, it's a 13-month mole survey. So at first, when they first turned up, the baseline, you can see it on the left, that is what it looked like. Oh, I don't know how to go back. Yep, we managed. And the doctor wasn't sure whether to operate or not. Then the system calls you back, takes another picture of that same mole, and you can see the evolution of the mole until the doctor decided this needs to be removed. They removed it in time and saved the patient's life. There you can see again what I was explaining, the depth of the mole and the position of the mole, so that the surgeon can then plan the excision very accurately. So this again has helped us improve our detection rate by about 20 to 30%. What does this mean? This means that you're actually increasing the chances of saving patients' lives. Last AI technology we are using is in breast imaging. Very, very important. You all know about breast cancer. We've got very good screening programs in Malta, and it is one of the most worrying and common cancers in the world. What you can see here, now what I'm going to show you is today we've invested in a unit called Lunit. We installed it in November 23, so 6 months ago. What you are seeing on the right is what the normal breast looks like under 3D mammography called tomosynthesis. What you're seeing on the left, you can see that AI has generated a map. There is a red, you see there's the red heat map. And not only is there the red heat map showing you where the worrying suspicious area is, it is also giving you this scores the suspicious area from a range of 0 to 100. 100 being very worrying, remove immediately, 0 being not worrying at all. Here, this lady has a score of 99 and the lesion at the top, and I don't know if you can see at the bottom there's another lesion which is scored at 30. So not so suspicious, but still would need attending to. Another feature that AI provides is that it tells us the density of the breast. So until 6 months ago, this was fully dependent on the doctor. The doctor examines the patient and it's very subjective. They have to assess how dense the breasts are and then apply the ultrasound technology accordingly. Now, with AI, this tells you exactly how dense the breasts are, and you can apply the diagnostic imaging tool appropriate for that patient. Another thing I want to explain to you is that the gold standard for breast imaging is, for breast screening, is you need double reporting. So the doctor, you go to the doctor examines you, does the mammography, reports your scan. That's not enough. The gold standard, I use a AI. Okay, so the gold standard is that then you need a second doctor to report it. Why? Because you are relying on one person, and it is very difficult to diagnose a small lesion on a mammogram. So with AI, we have replaced the second person plus. Okay, so this has become this is a huge leap in technology which patients are able to benefit from at 0 extra cost. Here you're seeing the same thing. I want to show you something else. So here you've got a patient in case 2. You're seeing a patient who has 2 lesions being diagnosed again with the support of AI. So the one at the bottom is a 54% suspicious rate, and the one at the top is 73. So both areas would need to be addressed. And this, although for us non-medics is not so obvious, here you have a cluster of microcalcifications. And before I came to this conference, I asked a radiologist to explain to me what I'm seeing, so that I know what I'm telling you. And I asked her to choose the most significant and effective and easy to explain images. She told me this image, what we're seeing here, is a cluster of microcalcifications, okay, which are very small. Now here they look obvious on AI, so you're seeing the color and you're seeing everything, but to the naked eye, this would have been very difficult to diagnose, okay? So AI makes that much easier. So to sum up the first section, all I have is one section left and then we're ready. The AI section, you can see that AI significantly reduces mortality, okay, and improves patient outcomes because we are able to detect areas of concern so much earlier, okay? The last thing I would like to talk to you about today is something that I heard you speaking about. Professor Buttigieg mentioned it, I think Celia mentioned it, JJ mentioned it, Digimed. Digimed is a telemedicine platform which we have launched last month. What is a telemedicine platform? Imagine a clinic or a hospital in the air, online, in a cloud. Okay, that's what it is. So it is basically a platform where patients can interact with doctors. Now, when I explained this has been 3 years being developed. And when I explained it to my board, my chairman, not my father, my chairman, because there's another board chairman who is, I don't know, 75, he told me as if I'm going to speak to a laptop to do a consultation. Forget it. And the investment, which was quite significant, initially wasn't approved. So I had to fight for this. I'm not going to go through the statistics so I don't bore you. You know how this works. So Digimed is an ecosystem. It's like going to a doctor without actually leaving your home. or from wherever, from the comfort of your home. So the patients interact with doctors, doctors interact with patients. You can send prescriptions to pharmacies, you can issue referral notes, you can send your claims to the insurances. Actually, I'm going to go through it now. So look, think about this. Today, the situation today, when you want to go and see a doctor, okay, you wake up, you call the doctor, you get ready, then you need to drive to the location, you park, you go, you wait at the, you register at the reception, then you have to wait to be seen. You are seen, you go to the pharmacy for the prescription. It's 2 hours, it's a big, big hassle. Whereas nowadays, all you need to do is download the app, find your doctor, hold the consultation, and it's all done in 5-10 minutes. Some of the features, okay, the main features, guys, is what you were mentioning before. So imagine this, applied to a person, an elderly person at home. And I will skip these obvious advantages, because what is interesting, this just shows that basically it's not only for GPs, so even specialists are using this platform now. But what is really interesting, in my opinion, is where we are heading to. And this is today. So these are, nowadays we have devices which can remotely monitor your parameters and feed into a system, okay? Which means that the doctor doesn't have to physically examine you most of the time, because we can measure blood pressure today already, we can measure ECG, we can measure temperature, pulse oximetry, breathing. Someone mentioned falls, we can also measure falls through a non-wearable device. So this is really taking healthcare to the next level, okay? This is where we are going to be able to make a huge difference and cost savings on our hospitals, both public and private. So to conclude, yep, I think it's a valid question. Are we truly understanding the power of AI in healthcare? I think it's becoming indispensable. Is this scary? Possibly. Is it an opportunity? I'd say yes. Is it a game changer? I'd say absolutely, absolutely. There is no other way. So with that, I conclude. I hand over to you guys. You're the smart ones. I don't, you're the ones who develop these technologies. So let's keep it up and keep it going. Thank you.
This brings to a conclusion the second session of our conference. We all enjoyed the videos on the endoscope before lunch, especially. I therefore guide you to the much-deserved networking lunch. I would kindly like to ask you to be seated back in an hour's time. That would be about 15:20, in order to proceed with the conference. Thank you for your cooperation. Lunch will be served at the Admiral Landing in level 5. That would be a floor and a half just below where we stand. Thank you and enjoy your lunch.
Jamie. Jamie is our chatbot. I think this, yeah, okay. Although it's going to be challenging with 2 screens now, but anyway, so we'll see. So this is a virtual agent, which we actually developed with EBO, or EBO developed it and presented it to St. James many years ago, or a few years ago. And today, Jamie handles about 25 to 30% of all St. James bookings. I'll just very briefly give you a demonstration about how it works. There should be some sound.
And you can select through speciality or clinician. Once you choose, you will be guided through the different services or a list of medical professionals offered by St. James Hospital, which makes the process of booking your appointment right at your fingertips. You can book the first available appointment or with a specific clinician, together with your preferred location, after which you are given a number of available slots by date, time, and clinician for your convenience.
Okay, so probably a lot of you are thinking, wow, what's so special about this? But don't see it today. You need to see it. When this was presented to us 5-6 years ago, okay? And I took it to the board, I explained to the board what we're going to be doing, and the feedback was, forget it. People don't want to speak to a robot. People don't want to interact with a machine. I had a doctor who actually told me this is the beginning of the dehumanization of healthcare. Okay, so this is the way people see and perceive technology. We decided to go ahead. We developed the system. Take-up was predictably slow. Today, the bar chart in red that you're seeing is the Jamie interactions. So the number of bookings, which the chatbot, which the virtual agent does. And by the way, we called it Jamie to give it some a human feel. And the blue bar charts are the calls handled and bookings done by our call center agents. Now, what's important here, I mentioned efficiency. In 1 year, so this is 2023, we had 277, almost 100,000 bookings done through our agents, physical replies. Okay, these are people, 30 women, because they're all women, I don't know why. And everyone, all they do from morning till night is answer calls, answer calls, answer calls. Jamie handled last year 1/3 of these, an additional 110,000 almost appointments. Okay, so this is very important for us. Why? Because the call center is a very difficult department to manage, to recruit, to work within. You get high turnover. They are lowly paid employees. So it is a very challenging department. So if we look at these statistics today, we realize that Jamie, our chatbot, is probably replacing the equivalent of 6 to 7 full-time call center agents, which is a huge help and an improvement in efficiency for St. James Hospital. I don't know if I'm being heard well. I have to move here. Okay, so that was the first part. There are another 3 related to AI. I will talk to you a little bit about AI in endoscopy. Now, this is something I have to do myself, unfortunately, regularly, with better outcomes. So, I don't know if you guys are familiar with endoscopy. Endoscopy is when the doctor needs to check your insides using a flexible instrument, a flexible endoscope. Now, what is the challenge? The challenge with endoscopy is that you're limited to what the doctor is seeing. With AI, so about 6 months ago, we changed our whole system, and we now have AI-supported endoscopy equipment. What's the difference? The difference is that if you look at the screen on the left and the screen on the right you can see that there's a boat, for example, over here. Now imagine that boat. Imagine that boat was a polyp or a growth or a tumor. In the first screen with our previous systems, and which are the systems which are available in all hospitals at the moment, except ours, you would have missed that polyp. Okay? So the AI enables the doctor to have a wider field of view, which is much more comfortable for them to be able to diagnose and to work. Here, you can see an actual polyp. That horrible-looking thing is a polyp. I do colonoscopies regularly because we have a family history of polyps, and polyps normally turn cancerous. So people who have polyps would need to do regular screening so that if polyps are identified, they are removed. Now, that is what a polyp looks like. That's what the doctor sees during the endoscopy. AI, so that's easy to see. AI will actually show you, it's a bit like, video games. It creates a square, a green square, around the polyp, and it shows the doctor where the polyp is. Now, this is an easy one to see, guys. But if you look at this image, now if you look very well, you'll see it. But if you are at the end of your list, 7 p.m., you've done 7 patients before, the chances of a doctor missing this polyp is very high. Very high. I've seen endoscopies being done. You see people on the screen looking, trying to check, the nurses. With AI, you don't need to do this anymore. The doctor simply goes into the colon, goes out, and AI will mark where the polyp is. So the doctor stops, focuses on the polyp, puts on white light, and as you can see a polyp there, which would have been very worrying and of great concern in a few years' time to this patient. But the patient has been saved because the doctor removed the polyp there and then. This is an actual, very short video of a surgeon performing a colonoscopy, and you can see the green squares showing the doctor where the potential polyps are. I think it's easy for you to see that it's very easy to miss. You can see the top left-hand corner. I don't know how you would know, how the doctor would have seen that, but okay, so it's quite challenging to see polyps which aren't very obvious in a colonoscopy and an endoscopy. So I think this gives you a good picture of how AI has really helped to improve the diagnostic quality and capability of our endoscopies. The third area that I'd like to show you where we're using AI is in mole mapping. So probably everybody in this room has moles. I used to have a lot of moles, and then I went to Mr. Franz Darmani and I went on the operating table and he removed about 20 moles for me. But anyway, melanoma is a very serious condition. So it is the 6th most common cancer and not easy to diagnose. Many times it's diagnosed late, and that means it might have already spread, leading to dire consequences. What do we have now? We've got what we call a photo finder, this machine is called. The photo finder, basically, here you're seeing a patient. On the left-hand side, you're seeing all the moles. Normally, a doctor, you'd have gone to a doctor, the doctor would have, you know what a dermoscope is? It's like a big magnifying glass. And the doctor checks each and every mole to see whether it is suspicious or not. With the photo finder, I don't know if you can see it on the right, I don't know about the quality of the pictures, but here, the photo finder has created a circle around each mole. Okay, there's a circle around each mole. And beyond that, what it will do in the next step, it will actually identify, and here you can see it better. In the next stage, you will see, it will identify from all those moles, 3 moles which need further attention. Okay, so the patient isn't going to go out full of holes, but the doctor is going to focus only on these 3 suspicious moles. This is what it will eventually look like, so you can magnify and see the length and the depth and so on of the mole, and then that leads the doctor to be able to take the necessary action and intervention. This is another patient, this is a Maltese patient who started, it's a 13-month mole survey. So at first, when they first turned up, the baseline, you can see it on the left, that is what it looked like. Oh, I don't know how to go back. Yep, we managed. And the doctor wasn't sure whether to operate or not. Then the system calls you back, takes another picture of that same mole, and you can see the evolution of the mole until the doctor decided this needs to be removed. They removed it in time and saved the patient's life. There you can see again what I was explaining, the depth of the mole and the position of the mole, so that the surgeon can then plan the excision very accurately. So this again has helped us improve our detection rate by about 20 to 30%. What does this mean? This means that you're actually increasing the chances of saving patients' lives. Last AI technology we are using is in breast imaging. Very, very important. You all know about breast cancer. We've got very good screening programs in Malta, and it is one of the most worrying and common cancers in the world. What you can see here, now what I'm going to show you is today we've invested in a unit called Lunit. We installed it in November 23, so 6 months ago. What you are seeing on the right is what the normal breast looks like under 3D mammography called tomosynthesis. What you're seeing on the left, you can see that AI has generated a map. There is a red, you see there's the red heat map. And not only is there the red heat map showing you where the worrying suspicious area is, it is also giving you this scores, this suspicious area, from a range of 0 to 100. 100 being very worrying, remove immediately, 0 being not worrying at all. Here, this lady has a score of 99 and the lesion at the top, and I don't know if you can see at the bottom, there's another lesion which is scored at 30. So not so suspicious, but still would need attending to. Another feature that AI provides is that it tells us the density of the breast. So until 6 months ago, this was fully dependent on the doctor. The doctor examines the patient and it's very subjective. They have to assess how dense the breasts are and then apply the ultrasound technology accordingly. Now, with AI, this tells you exactly how dense the breasts are, and you can apply the diagnostic imaging tool appropriate for that patient. Another thing I want to explain to you is that the gold standard for breast imaging is, for breast screening, is you need double reporting. So the doctor, you go to the doctor examines you, does the mammography, reports your scan. That's not enough. The gold standard, I use a AI. Okay, so the gold standard is that then you need a second doctor to report it. Why? Because you are relying on one person, and it is very difficult to diagnose a small lesion on a mammogram. So with AI, we have replaced the second person plus. Okay, so this has become this is a huge leap in technology which patients are able to benefit from at zero extra cost. Here you're seeing the same thing. I want to show you something else. So here you've got a patient in case 2. You're seeing a patient who has 2 lesions being diagnosed again with the support of AI. So the one at the bottom is a 54% suspicious rate, and the one at the top is 73. So both areas would need to be addressed. And this, although for us non-medics is not so obvious, here you have a cluster of microcalcifications. And before I came to this conference, I asked a radiologist to explain to me what I'm seeing, so that I know what I'm telling you. And I asked her to choose the most significant and effective and easy to explain images. She told me this image, what we're seeing here, is a cluster of microcalcifications, okay, which are very small. Now here they look obvious on AI, so you're seeing the color and you're seeing everything, but to the naked eye, this would have been very difficult to diagnose, okay? So AI makes that much easier. So to sum up the first section, all I have is one section left and then we're ready. The AI section, you can see that AI significantly reduces mortality, okay, and improves patient outcomes because we are able to detect areas of concern so much earlier, okay? The last thing I would like to talk to you about today is something that I heard you speaking about. Professor Buttigieg mentioned it, I think Celia mentioned it, Jaja mentioned it, Digimed. Digimed is a telemedicine platform which we have launched last month. What is a telemedicine platform? Imagine a clinic or a hospital in the air, online, in a cloud. Okay, that's what it is. So it is basically a platform where patients can interact with doctors. Now, when I explained this has been 3 years being developed, and when I explained it to my board, my chairman, not my father, my chairman, because there's another board chairman, who is, I don't know, 75, he told me as if I'm going to speak to a laptop to do a consultation. Forget it. And the investment, which was quite significant, initially wasn't approved. So I had to fight for this. I'm not going to go through the statistics so I don't bore you. You know how this works. So Digimed is an ecosystem. It's like going to a doctor without actually leaving your home or from the comfort of your home. So the patients interact with doctors, doctors interact with patients. You can send prescriptions to pharmacies. You can issue referral notes. You can send your claims to the insurances. Actually, I'm going to go through it now. So look, think about this. Today, the situation today, when you want to go and see a doctor, okay, you wake up, you call the doctor, you get ready. Then you need to drive to the location. You park, you go, you wait you register at the reception. Then you have to wait to be seen. You are seen. You go to the pharmacy for the prescription. It's 2 hours. It's a big hassle. Whereas nowadays, all you need to do is download the app, find your doctor, hold the consultation, and it's all done in 5-10 minutes. Some of the features, okay, the main features, guys, is what you were mentioning before. So imagine this, applied to a person, an elderly person at home. And I will skip these obvious advantages.
Because what is interesting, this just shows that basically it's not only for GP, so even specialists are using this platform now. But what is really interesting, in my opinion, is where we are heading to. And this is today. So these are, nowadays we have devices which can remotely monitor your parameters and feed into a system. Okay? Which means that the doctor doesn't have to physically examine you most of the time, because we can measure blood pressure today already, we can measure ECG, we can measure temperature, pulse oximetry, breathing. Someone mentioned falls, we can also measure falls through a non-wearable device. So this is really taking healthcare to the next level. Okay? This is where we are going to be able to make a huge difference and cost savings on our hospitals, both public and private. So to conclude, yep, I think it's a valid question. Are we truly understanding the power of AI in healthcare? I think it's becoming indispensable. Is this scary? Possibly. Is it an opportunity? I'd say yes. Is it a game changer? I'd say absolutely. Absolutely. There is no other way. So with that, I conclude. I hand over to you guys. You're the smart ones. I don't, you're the ones who develop these technologies. So let's keep it up and keep it going. Thank you.
This brings to a conclusion the second session of our conference. We all enjoyed the videos on the endoscope before lunch, especially. I therefore guide you to the much-deserved networking lunch. I would kindly like to ask you to be seated back in an hour's time. That would be about 15:20 in order to proceed with the conference. Thank you for your cooperation. Lunch will be served at the Admiral Landing in level 5. That would be a floor and a half just below where we stand. Thank you and enjoy your lunch.
Manufacturing has been active locally for over 2 decades, like over 20 years. How has this sector evolved during this time? And my second question would be, what are the main strengths you observe in Malta? So changes and strengths.
Good, thank you. Thanks for calling me here for this panel. I think we've been hearing all day today how technology has been evolving, how digitalization has been making its roots into healthcare. And that's nothing different than manufacturing. I mean, manufacturing technologies have been evolving. We've been seeing a lot of more automation in manufacturing, more advanced manufacturing technologies, and even more access to technologies like, once again, the investments needed in the past to install high-tech equipment is nowadays more accessible, which is making more businesses more affording advanced manufacturing technologies. So as a first major change over these years, I see the advancement in technologies. Our previous speech was also then around more regulation, and the panel here knows how regulated our industry is, but the changes in regulation, I would say over the last 10 years, driven by the EU MDR, has made manufacturers be more innovative, be more challenged with meeting the new expectations, but in the end, we're manufacturing much safer products. We've seen the list of toxic materials, or let's say unsafe materials, not to be dramatic, that are being prohibited by the EU MDR. There are also other considerations that manufacturers have to look into, which maybe in previous years have been overseen, like the usability of the product, how easy it is to prevent errors while using the product, how intuitive the products are. And from the user side, these could be expected. Nowadays, we're expecting that we'll take a device and it will technically even tell us itself what we need to do without us even having to think about it. Once again, we need to ingrain these thoughts in our development, in our manufacturing of products, because otherwise, once again, will be overtaken by other industries, other competition. I would say the last major shift that has occurred in the industry I've seen is the way that healthcare is doing business. I mean, at the end of the day, healthcare institutions are mostly state or government owned, but then there are also private institutions that are there to save patients, to save lives, but at the end of the day also to meet the expectations of their stakeholders, meaning making a profit. So cost pressures in healthcare has been seen throughout, but even I would say in the recent years, driven by COVID and the supply chain issues that has driven around it, some practices that have been introduced during COVID have taken root and are now the new norm of how business is made. So that in itself is driving more tougher competition, I would say safer products, but then higher expectations by the users on the manufacturers with respect to quality and customer support. So that's my answer to the first part of the question. The second part, like the strengths that I see here in Malta, at least in the healthcare manufacturing industry space, is, I would say, the cost competitiveness with respect also to the skill set of the workforce and the work ethic. I mean, there's a good balance between being cost competitive in Europe, but still having a highly skilled, highly ethical workforce. And I think that makes, let's say, a good incentive for healthcare product manufacturers to set up ground here. So.
Thanks. That's a really good answer. And I love that you mentioned workforce, and especially the advancement of the technology. Maybe we'll be touching upon this a bit in the next question, but I don't want to probe you too much. So my next question is really up to Engineer Victor Spiteri. I'm going to move from medical devices, although we'll probably see some similarities, from medical devices to pharmaceuticals, especially manufacturing, right? So can you describe the role of engineers in pharmaceutical production? And again, second question. So the role, and what are the key technical challenges in the area?
Thank you for having me.
Of course.
To start off, in the pharmaceutical manufacturing sector, it's basically an all-encompassing role for the engineer. Starting off, there are the projects and capital projects which necessitate the installation of the manufacturing plant in it, and also other improvements. Case in point, currently at Teva, formerly activists, for whoever is old enough. We found a bottleneck in the lab department, so we're extending the lab sector. This involves building surfaces and all the utilities that are needed. Going forward from that, with facilities and utilities, once installed, they need their maintenance. So there's the plant and utilities engineer, which takes care of all the different services, be it compressed air, chilled water, processed water, purified water, used in the final cleaning of all the tooling, for example, that are product contact. So there's a set of standards that needs to be provided to that purified water. There's the HVAC and the humidification of any low humidity needs that a product could possibly have. Also, for example, fixtures, there are products that are light sensitive. So you would need yellow lighting with a particular lux level that needs to be thought of and designed beforehand when installing the whole system. And also, obviously, the preventive maintenance and continuous improvement of all this equipment. Going from that, then all those services will tackle or supply the different equipment within both packaging and the manufacturing area of the plant. So Teva has both manufacturing, so starting from powder, granulating and compressing to tablets, coating as well, passing on to the packaging department where it's packaged into the final product. All those equipment, different equipments, dispensing bays, granulation bays, fluid bed dryers, coating machines, blister lines, all those have different requirements. So you'd have the project engineer coming in to install all those different equipment and liaising with the facilities engineer to give all the services. And then obviously you'd need the maintenance. So there's the maintenance engineer, which takes care of the technicians, has a team of technicians that would maintain, take care of the preventive, any corrective actions that need be, spare parts management, root cause problem solving. So any issues, any deviations that would arise from malfunctions or parameters that are not well done. There is a root cause problem solving session typically where we decide on what CAPAs will be implemented so that this does not happen again. And also given the different products which are produced. So in our case, I need to read out these because I'm not good with numbers. We have 158 product strengths. We package 2.3 billion tablets, 64 million blister packs finally, and 1,900 pack presentation. And those final pack presentations basically entail all the different tooling that needs to be bought, maintained, and designed because he was my mentor for a couple of years in Teva, back Actavis. So yeah, the design is a very, very nice part of the whole process. So you have tablets coming in, a launch with a deadline. You need to design the blister pack, which equipment it will use, because not all products pass through the same stream of equipment. Some use the FPD, some have dry blending, we call it, so they're not wetted. Some use ethanol. There's a whole different process. And then there's the design of the blister pockets, and in it the engineer would need to think ahead as well as see what deviations and problems they had in the past to try and put in the design something that would help out the operations. Also, then there's the reliability function where we try to maintain the best possible OE, the best possible efficiency of the machines, while always maintaining quality and reliability. And in that regards as well, sorry I'm taking long, but
okay.
There are a lot of functions. I started off as a validation engineer, so the validation engineer encompasses overlaps the quality and engineering function. So basically he would test against functional specifications and user requirement specifications of all the equipment, and create a test script and make sure that that equipment would do its job reliably and continuously without producing any defective product. And the qualification engineer basically gives the stamp that an equipment can be used. Without his role, which is typically from start back to the end of the life cycle, we wouldn't be able to work with the equipment. So that was the first question.
Yeah.
As to the second question, so technical difficulties, in my opinion, as my friend here mentioned, it's a very regulated market. Stringent requirements, changing as years go by. So beforehand, for example, give an example, we used to put a batch number and an expiry date just on the pack, and that's good to go. Now it's serialized. Each pack has a dedicated serial number. There's tracing of that product going down the line from when it was first packaged down to the pharmacy, where the pharmacist has to scan that to decode and make sure that it's not counterfeited, for example. That was a whole project. And with it came the tamper evidence, so to make sure that there's no tampering of the product. All these requirements, ever evolving, take not a toll, but make the engineering profession in this sector very, very interesting, so to speak. But it is with the ingenuity of the engineer that these are overcome, basically.
Well, you can see me. I think everyone can see me writing notes, because it helps me think rather than make sure that I understand your answer. And when I was asking, so the first question was like, okay, what's the role, right? What's the role of engineer? And I have like facility, written down life cycle, problem solving, quality, design, challenges. So it's not just from start to finish, the role of engineers. It seems to go round as well, which is, yeah, it will have quite a toll. So thank you for that. You touched upon regulatory affairs and even Engineer Grima before you. And my next question is mostly about that, and it's to Mr. Kenichro. So I'm going to jump back to medical devices, right? So medical devices are subject to stringent compliance requirements. We've already hearing this already. From a regulatory standpoint, what challenges and opportunities do you see in the local sector? And how does engineering knowledge intersect with regulatory processes?
Okay. So, okay, on this, I mean, most people see regulation as an obstacle, and it is an obstacle, as other people have mentioned. You know, it's not something I just create something new and place it on the market. So in a way, you can say that, you know, it is a challenge to get over the problem of regulation. At the same time, and since if we look at the local level, I mean, we're on an equal playing field with the rest of the EU and more or less with the rest of the world. What I mean by this is that a manufacturer in the US has to meet the same EU regulations if they want to sell in the EU, if they want to get their CE mark, as we do here locally. So from that, in that regard, if we look at the EU regulations, it is a big challenge in itself, and I mean, I've worked with startups, even locally, who they have a brilliant idea. They're more or less, they think at least they're prepared to get to the market. And then, unfortunately, you look at their documentation, which if they have any documentation, and it's just not up to scratch. And a lot of it is a bit of a bureaucratic exercise. It's, you know, you need to have device description document, you know, you can put that easily together. But what the ideal thing to do is when you're at the design stage, you begin to look at in the previous talk with Oliver, he mentioned those general safety and performance requirements. Those are something which you need to take into account at the design stage. I think that if a company does go through those steps, it will take longer, it will probably cost them more, but at the end of the day, when they come for their submission to, let's say, a notified body, it will be, you know, easier in the long run to get through that. Another big challenge is the cost. The cost of getting a high-risk product onto the market, onto the EU market at least, you know, it can be quite astronomical. So you need to go through your clinical trials. You might be lucky and you may be exempt from clinical trials. That would be ideal. And as previous speakers have mentioned, there's so much you have to think about in terms of your technical standards and your biological evaluation, your usability. So these are big, big challenges. Another thing which you both mentioned before is it's constantly changing. The MDR was published in 2017, but since then, there's been constant influx from the EU of different guidance, and we call it guidance, but it's really something you need to follow. Let's not say it's a law, but you have to follow that. On the local level, with the medical devices being regulated by the Malta Medicines Authority, they have recently released some guidance which it doesn't affect the manufacturers as such, it affects more the importers and distributors. And I think you know about this yourself. And they have been, it is a challenge for them to implement this new guidance which talks about, a good distribution practice, quality management system, hiring a medical device registered person. And when you think about some of the smaller, really small distributors or importers in Malta, it's a huge burden for them. But again, when we look at all of these challenges in obtaining the CE mark, for example, then we can take into account the opportunity. Once you get your CE mark, you can sell in all of the EU, which is obviously fantastic. But there are also some other jurisdictions which currently accept the CE mark, at least, for example, even the UK right now, they would accept the CE mark. They have their own regulations, their new regulations are upcoming, but for the time being, they'll accept the CE mark. And also jurisdictions like Saudi Arabia, South Africa, and so many others all around the world, which really look at this conformity as, okay, it's safe, you can place it on our market. So that's the opportunity I would see from that end.
Well, it seems that, the advice that you just gave, it's not just for the regulatory affairs. I feel that it's life advice as well. So it's easier in the long run if you invest at the start.
Exactly.
You see a burden as an opportunity. The fact that you mentioned, actually, thank you for answering, not just locally, but out of Europe. I think that's very eye-opening. Thank you. My next question actually goes to Engineer Cilia. So we're going to back talking about us, about engineers. So engineers play a crucial role in production and quality assurance. What opportunities for excellence does the engineering profession provide in a sector with strictly defined requirements?
Multiple opportunities. First, I would like to touch a little bit on the regulatory aspect and the engineer in the industry, because, and I would like to throw a little bit stones in the water as well for the discussion over here. So, when I joined the pharma industry around about 20 years ago, I would say, one of the very first engineers in manufacturing, if not the first one. So it was an environment of pharmacists and scientists. So one of the challenges of the engineer is to explain in simple and clear terms how we are mitigating the risks, from the design up until when the product is actually arriving to the patient. And that's one of the challenges that we engineers need to constantly face and adapt, because normally you will be challenged and you have to explain this to people that are not technical. So that's another aspect. Now, excellence. Okay, so when we talk about excellence, we're normally trying to address waste. So how can we reduce waste in its various forms? How can we reduce variability? And the other pillar is normally inflexibility. So waste, when we talk about waste, we talk about the efficient use of resources. And it's not about, today we don't even talk about doing more with less. We already have less. So today about doing more with what we have. Yeah, so and there's where we come in as engineers, because it's always important, I always say, to understand the current condition. What is driving what? And it's there that you need the technical expertise to understand why something was designed in a certain way. Why today we are saying that this process needs to be done like this. And again, the next stone in the water, then we as engineers need to be able to be challenged. and accept that there might be a different way how to do it. And it's not easy because most of the times we were the people who designed it and implemented it. So in our mind, it's perfect. Yeah? So this is again another aspect where excellence comes in. The other aspect is how we reduce variability. So how we design systems, equipment, whatever, that has what we call I'm trying to bring a little bit of lean methodology here, the undo, the stop and notify. So does our systems notify us if something is going wrong? Are we able to identify it as early as possible in the process or in the supply chain? Then there's the other concept. Do we have an element of foolproofing in our designs and our systems and our manufacturing, the concept of GDOCA? Usually this is where engineers come in to try to bring excellence in the process. Last but not least is the level of inflexibility. And being an island, and I relate quite a lot to what Joe was saying before, being adaptable for Malta is crucial because we do not have the economies of scale that you find in Europe and in other places, and I work quite a lot outside the island. So being able to constantly adapt and change is crucial for the island to remain competitive. So that's the third sort of aspect of excellence, basically.
Thank you. So as engineers, we're not only expected to have a lot of technical expertise. It seems, and I'm going to quote you here, that we need to explain to people who are not technical how we can explain that. And it's so important. I think every one of us, right, has to explain very complex stuff to other people very, very simply. And you've just done that very well to me. Thank you.
Normally we say if we are not able to explain it as a process, then we don't know anything about the process.
I agree. Good. Well, thank you for that. My next question is about, it's about the economy, but we have Ms. Joanna Gatt here. So let me just start off with what I want to say. So medical devices and pharmaceuticals are significant to Malta's economy. So that's why I touched upon economy. What challenges does the Malta Chamber of Commerce identify for this sector? And are there any short-term and long-term opportunities that you actually foresee?
So first of all, thank you very much for inviting me. It's a great honor to be here. I agree with you that medical devices and pharmaceuticals contribute to the economy, but not only in monetary terms, but also because these are products that have a great impact on the quality of life, on our quality of life and our well-being. So yes, I think people who are working in this field have a great responsibility. Just to put this in perspective, the members of the healthcare business section of the Malta Chamber of Commerce are marketeers and distributors. So we're not manufacturers, but we purchase from the manufacturer, and we are involved in the value chain from the manufacturer right to when the patient is given the product, be it a medical device or a pharmaceutical. So to really start straight away into the challenges we face, especially regarding pharmaceuticals, our main challenge is market access of innovative medication. What is market access? Market access is getting the right medicine for the right patient at the right time, every time. And basically, this morning I know we spoke about personalized medicine, and it's quite useless if you have a process in place to diagnose, to see in cancer patients, which is the right medicine for that particular cancer, breast cancer, for example, that was mentioned, if you're not going to have access to the treatment available at the right time. So this is something that we are challenging. FPA, which is the European Federation of Pharmaceutical Industry, come up with a publication every year called the Weight Study, and they assess each European country, not only EU member states, but across the whole European region, and they assess how quick the countries were to actually make the new products accessible to patients. And unfortunately, Malta always is at the bottom, three steps down from the bottom, or with Turkey and Albania following us. So this is something where we really want to work on, because it also means that there is inequality between patients across the whole of the EU, and it can mean life or death. So basically, as a solution to the government, because the government, for example, comes out with tenders for a whole class of drugs, the same class of drugs, but they only choose one, the cheapest. But in reality, all the drugs, have a place in the treatment, in the personalized treatment of the patient, because one size does not fit all. So what we are trying to say, although we are competitors, it's great when you win one and the others are out for the next 3 years, but we're not doing justice to the patient, because I may need not this drug, but the other one, because I might have some other ailment. So we're saying all products should be available, and the right treatment has to be discussed between the patient and the prescriber. So we're trying to introduce multiple award tenders, and the government seems to have an appetite for this. But of course, we have to find a way of making it a simple procedure that again will not affect the budget. However, through the Malta Community Chest Fund, some of these drugs are being given, but then we all know that the government bails the Community Chest Fund out when it needs more funds. So why not, from the very beginning, come out with the right tender, and obviously being a tender, the prices will be better, so, more sustainable. So that is the short-term solution opportunity that we have, and for a long-term solution, we need to look at the bureaucratic processes from the moment a product is registered through the European Medicines Agency to make it available on the government formulary list. These procedures just take you around in circles and never get you anywhere. So, and I think all stakeholders, including the payers, have understood this, and we will be working on trying to find and streamline the procedure so that Malta, the patients in Malta will get quicker and easier access of their medication. And if I may just touch on medical devices, because we, of course, are also distributors of medical devices, as Kenneth mentioned, the MDR and the expenses, and obviously the need for an MDR RP of anybody who puts a medical device on the market. There is a cost to it. And with all these new costs and ongoing tenders whereby you cannot increase your prices, but your margins are, drastically being reduced, that is a challenge. But I think with all the notification of medical devices and all the new regulations, what I think worries us is enforcement, because a lot of distributors, I think, are not being captured. So, you know, we need to have a fair playing field here. You can't have some distributors being, you know, obviously regular, and we're fine by it. We embrace it because it means product, you know, it means product quality, and it means safety for the patient. So we embrace it wholeheartedly, but everybody has to follow the same rules. One area whereby I know the authorities are also working on is the area of aesthetic medicine, whereby the supplies, which are not only medical devices that are being injected, but also pharmaceuticals, may not be being administered by the right medical team, or a medical team that may not be registered with the Medical Council of Malta, which is compulsory. Also, the actual suppliers. How are they coming into Malta? Are they coming through the normal distribution channels that is totally controlled from A to Z? Or are they coming in suitcases, you know, which means that it's highly irregular and at great risk to the patients. So the opportunity here that I see is that there is awareness of this, even with the authorities. So it's great to have these discussions continuously with all the stakeholders, and that they are looking into it very, very seriously.
Well, thank you for mentioning aesthetic medicine. I mean, we're seeing all around us, right? Everyone chasing the fountain of youth. So yeah, that needs to be, you know, pretty much sought after. And thank you for also mentioning, again, a recurring theme in your discussion, obviously, well, I mean, you helped us realize the short and long-term needs, but the inequality, justice, fair play, the impact of quality lives, these are all things that I'm quoting from you and so important in our, you know, in our work. So thank you for mentioning that. Speaking of recurring themes, my next questions are, it's about the highlighted digitalizations. Apologies for that, a lot of S's. So in the hope of making this informal a bit, I'm going to drop the titles and direct it to your first name. Again, may I please welcome anyone who would like to comment, stop me, I don't mind being interrupted. We're a few less people, so hopefully we'll be less shy. So, sorry, I thought I saw a hand for a minute. Anthony, Victor, and Joe. Again, today's program highlighted the digitalization as a recurring theme. How could this sector benefit from these tools and developments? Can I get a few answers from you?
Yeah, so, I mean, again, one of the mantra of operational excellence is that, you know, in God, we say in God we trust, others bring data. So, you know, having an understanding of what is going on is crucial. And that's one aspect, yeah, so that, you know, you build enough data to understand what is your problem and try to understand why a function of 1, 2, 3x. So that's one, I would say, very common areas that we are utilizing, in this case, more digitization. And then, and this was mentioned before as well by JJ, is the aspect of predictability, where it is being used as well, and we are tapping it on. One aspect is in the concept of total productive maintenance, so we're using it for predictive maintenance, basically trying to understand when something is going to fail, you know, collecting data from equipment that is obviously prepared for collecting data, and then analyze it to, again, predict what is going to happen. So again, bringing the element of efficiency because you can identify the problem before it is happening. The other area where it is being used a lot is in R&D, especially when drugs are being still developed. Especially in biotechs, they run a lot of correlation analysis, design of experiments. So, you know, previously we were used to call these the Six Sigma stuff. Today, with the help of AI, this is moving very much at a fast rate. And we have seen it as well in COVID. So it was one of the reasons as well why the vaccine was, it was a biologic, why it was able to be developed so quickly as well.
Thank you. And I love how you explained very quickly the 1, 2, 3 yes, again, the data. Thanks.
Yeah, I think adding to what Engineer Spiteri was saying, there's an endless array of opportunities for use of digitalization and AI in manufacturing. It is being used, and eventually we're also moving to closed loop data management, where we usually find whole manufacturing facilities that are technically people-less. So those are opportunities which I think AI is bringing ahead of us. We've also touched a point about the cost to develop, to register, to clear products, which is driven by a lot of tighter requirements, much more scientific data that need to be generated. So AI in that space can be used as a predictive model, can be used as a, informative way how to provide safety evidence on your product without having to go through, let's say, the clinical trials or the fully fledged verification or design verifications that would be needed. On the other side, I think we heard enough this morning say about how AI can be used in the healthcare space itself, and how AI is, I would say, an expectation nowadays or in the coming years to be introduced in the medical devices. So I think there are the opportunities there. I think from a personal note, the regulations still need to catch up with AI, meaning that once again, there's a lot of data that is being generated, that is being captured, and in the space of AI in healthcare, there's a huge debate, or at least there's a still unclear debate or understanding of regulations of who owns the data, who can manipulate it, who can access it, and all of that. So I think that's an opportunity that is in front of us that we have to prepare ourselves for, to be able to introduce higher technologies, more knowledgeable devices in our healthcare systems.
My take on this, coming from the operational background and the manufacturing sector, and touching up on, I forgot the name, sorry, lady, that product needs to be available as quickly as possible to the patient when it's needed. Digitization would help in making the process more efficient. Taking in case sometimes we have markets which are out of stock. So basically, and even the ethics behind it, you have a market, a place where the medicine is not available. They want to buy it, they cannot. They're waiting for the manufacturing plant to finish it back and transport it to the location needed. And there comes the efficiency that is needed within the plant itself. Out of stock is a big deal, so we can easily say it does not suit our planning needs. We have to do more changeovers. The efficiency would drop, so they'll have to wait a bit more. But that is not how things should be done. So we change the plan. And over there, that planning change would be a big deal. There's a lot of material that needs to be sourced. The plan would need to shift. There are different equipment that needs to be used and freed up. So over there, I think AI would help a lot in the planning sector, making the production more lean and the flow much more consistent to get the product out much more quickly and easier. We have a metric, a KPI, cycle time. So from when the order comes in to when it is packaged, we managed, not through AI, but hopefully in the future, we could jot in that. So we reduced that by 50% from 60 days to 30, and moving forward to reducing it even further. We have introduced, we did a pilot project last year on augmented reality, so to streamline the changeover procedure, make it more standardized, and obviously keeping the quality intact and making it faster, moving forward faster. You change over to a different product faster, so you can get the product to the market much easier. We're currently qualifying it. So we did a pilot project last year, had very excellent results. This year, in a month's time, packaging department should be going forward with augmented reality. And augmented reality also, we found also other niches where we can use it. So the technician, maintenance, that's right. The technician would wear the HoloLens. He would see an overlay of the part that he's repairing. Has remote maintenance from the engineer, if it's in the silent hours, from the supplier back in Germany. Most of our equipment is from Germany. So the SME would be remote connecting, seeing what the technician is seeing, and repairing more quickly, getting the product more quickly out on the market. So digitization is a key improvement in our sector, and I guess it's up to us to use it as much as possible to help us and the patients finally.
In fact, Victor was actually in the midst of COVID. He had to do an upgrade with the engineer sitting in Germany, so it was one of the areas where he definitely had to use it over there. Another aspect as well linked to, I'm seeing it coming as well in stock management. Either spare parts stock management, how to ensure that you always have the necessary spare parts in store without busting your cash flow, not holding a lot of cash in your cabinet, and linking it to the information that is coming from the machines on the condition-based aspect of maintenance. So understanding when the part is actually going to fail, and ensuring that as much as possible be just in time with part availability. So it's being used in that aspect as well.
Thank you. Well, Victor and you both touched upon the efficiency, the cash flow, and even Joe at one point mentioned people less manufacturing due to AI. But thank you so much for also mentioning your personal point of view that the regulation needs to catch up. I mean, we're seeing how important AI is, but the fact that it needs to catch up, it made me think a bit. But I don't have any comments on that. So thank you for your really good answers. I know I'm simplifying what you just said very much, so sorry for that, but hopefully it helped me to my thought process as well. I am at my final question now, but it's going to be 2 questions, but final point. So again, I'm going to drop the titles, if you don't mind. Joanna and Kenneth, this one is for you. So let me just start with an introduction. The production and delivery of medical devices and pharmaceuticals actually contribute to sustainable development goals. My first question is to Joanna. What are the business community's views on the sustainability throughout their life cycle? And the second question would be to Kenneth. How regulations, especially for the medical device sector, are adapting to address sustainability in the sector? So I just realized that I just said a lot of words. Practically, we're going to focus on the sustainability for medical devices and pharmaceuticals. And Joanna will be answering the first question about the business community views. Sorry for repeating myself, but I realize I have a chunky paragraph here.
No problem at all. Actually, thank you for this, interesting question, because we're very proud to have a policy executive on sustainability at the Malta Chamber of Commerce. And this sustainability executive is actually part of the Enterprise Europe Network, Malta. So they're in a position to really assist people to kickstart their sustainability journey. And it could be interesting even for people over here today. So yes, the business community, of course, is very conscious of the sustainability responsibilities. Of course, not only towards the environment, vis-à-vis packaging, vis-à-vis waste, etc., but also in the responsibility towards the well-being of the stakeholders, the patients, the healthcare professionals, regarding training, etc. So we're looking at the ESG factors and values in its entirety. Our members are mostly SMEs or SMEs, and we're not obliged to do any reporting, ESG reporting. But as I believe Mr. Bisazza mentioned, we are part of the value chain of large companies. So between us, we represent all manufacturers, basically, of pharma and medical devices. So we are also now being requested, for certain data. And of course, even our CO2 emissions, so that they can, because we'll be their scope 3, but in reality it's our scope 1 and 2. So, so there's a lot of conscious awareness, and the government, in actual fact, has come out with some grants to help SMEs report on the Malta ESG platform. And I know there's a lot of interest over here, although for SMEs it is not obligatory to report. But once you start early, and then when it starts to become more impegnative, you already got yourself into that mindset of reporting, and it's great because you can use, for example, we just did 2022. You use that as a benchmark now as you go along. So the journey, the sustainability journey, becomes very interesting. As distributors, our priorities can go from product innovation. As I mentioned before, market access is huge on the priority list for especially the pharma industry. You've got business ethics, good corporate governance. For example, we get annual training from the company I work with, and then annual training from each supplier on anti-bribery and corruption, so that you will realize where the red flags are, because what happens in Malta, and you do something untoward for company X, they will be liable to really, really high fines because of what happened in Malta. So there's this very crucial link. This job, although extremely satisfying, comes with a lot of responsibility. So this is something all the companies, all the distributors take extremely seriously. On top of that, of course, you've got diversity, equity, and inclusion, which makes a great workforce, and then, of course, the impact on climate change, as I mentioned, and somebody mentioned stock management before, and it starts from the stock management, because if you have bad stock management and you're purchasing quantities much higher than the demand, what's going to happen to these products? They're just going to be thrown away when they expire. So everything is a process. So even starting from stock management. And then again, I think that's another thing that we would like to see is proper disposal of expired goods at the individual. There is a system that you can go to the pharmacy because they have bins there, but how much is it actually used? And how many are being flushed down the toilet in actual fact and ending up in our wastewater, you know? So to answer your question, to round up, sorry I took so long.
It's okay.
Yes, you know, we are very aware and taking sustainability very seriously from all aspects.
That's really good to hear. And I was quite impressed that, you know, we're seeing SMEs reporting even though they don't need to. And if I can quote Kenneth, actually, you know, a burden is taken into an opportunity, which is, you know, exactly what you need to do in your place of work.
Absolutely.
Yeah. So, Kenneth, I'm going to focus on you a bit now. So, in terms of regulation, I'm going to ask the questions again for the audience, really. So, how are regulations, especially for the medical device sector, adapting to address sustainability in the sector? So, again, about sustainability, but Kenneth will talk to us about medical devices.
Okay. Funnily enough, if you look in the medical device regulation, when you look up environment, for example, it doesn't talk about the environment as we think of it. It talks about the patient environment. So it doesn't focus directly on, you know, these sustainability goals which we're talking about, but it leaves it up to other directives, which, to be honest, Oliver Bezatza really, you know, gave a good summary of all of them. I think indirectly, two things I can speak about is that previously, so there have always been these single-use scalpels and surgical instruments which are being used once and then thrown away. And like that, you're eliminating 100% the type of contamination, any cross-contamination. But what the EU regulation does is it makes it easier to a certain extent for some manufacturers to manufacture reusable surgical instruments. Now, previously, it might have just been, okay, we're going to design this scalpel, again, made out of this material. They can throw it in a sterilizer, and that's it. But the regulation, although, again, if we talk about the challenge, it is increasing the regulation. There's a bit more of a burden on the manufacturer. But they now need to prove that it can be reused, and for how many cycles. It might even need to be indicated on the box, on the labeling, how many cycles of reuse it can go through. Another thing which I think the regulation leaves room for is the reprocessing of single-use products. So there are some hospitals which don't throw away single-use products. Instead, they are now regulated in that when they sterilize their products, they have to meet certain requirements, they have to document certain things, ensure that there's a certain level of traceability. And if they don't want to do that, they can subcontract it out. But at least the regulation is no longer saying, oh, it's single use and that's it. Yeah. It's now leaving room for this sort of reprocessing, and which at the end of the day, it does help the environment in that aspect. And then we've been mentioning a lot on packaging. There are, even in the standards, it talks about reducing the level of packaging whilst, and that's where the challenge is, maintaining it has to maintain the safety and performance of that device. It cannot be damaged in transit, but at the same time, you have to reduce the level of packaging and use different types of packaging to meet these other requirements.
Well, it's good to hear, obviously, that we're trying to reduce our effect and the single use. Obviously, this all falls down to people working in healthcare, the responsibility, and we have to, what was it? We already have less, but need to do more with less. No, we already have some.
We already have less, so we just need to do more.
Thank you. I wrote it down, but I love the quote, actually. Well, this brings us to the end of the panel. I don't see any questions, so I see. Great. Thank you for making my life easier, please. Can we get a mic, maybe, or? Or, okay.
Thank you. My question to the panel is, when you look at aspects that we saw, okay, so regulatory compliance, mostly for manufacturers and importers, yes, okay. But coupled with the telemedicine aspect and the potential increase in that use that Jean-Claude named before, do you see that Europe, to some extent, it's failing its own citizens, like perhaps it did to some extent earlier on in the semiconductor industry and more recently on automotive, by giving a competitive advantage to other areas, particularly the Far East, if telemedicine gains more ground, and then in that case you might have a doctor or potentially an AI agent in other areas of the world providing medical consultation and possibly prescribing or dispensing as well personalized medicine. Do you think that the current regulatory framework is protecting Europe against that? Thank you.
Anyone from the panel would like to take that on?
I'll be honest in terms of, I don't know if anyone else wanted to, I'll be honest, I cannot really answer that question myself. I mean, from the aspect of the medical device regulation, software is regulated and it is increasing. I know you had some concerns on it, but in terms of, let's say, artificial intelligence, like we saw in diagnosing from CT scans, MRIs, it is quite regulated, and it's not, anyone can place on the market. With respect to telemedicine, I cannot speak so much about it because it's not really a medical device, and it might be a bit, as far as I know, when you look at the definition of a medical device, in itself, it is not treating a patient. So it's more of I would say, a solution to link a healthcare professional with a patient. So personally, I'm not too sure. I don't know if anyone else knows how that might be regulated, but. Okay, I don't know.
I think it is, but I would probably have to do some research. I know someone who actually is a doctor and wanted to do that service. They wanted to provide services as medical doctors online. And I know there's also some psychological service being offered. There's BetterHelp, which is very popular. I'm just commenting without providing you an answer. I'm pretty sure it should be regulated, right? So, I mean, to practice as an engineer.
Or the medical devices that would follow up upon further to that consultation service.
I'd say it's a really
I
good
don't
point.
see a way that could be actually limited or regulated effectively. I mean, today you could just go in any site. I did it just as a quick trial while we're discussing, and buy off any, I don't want to name names, but any site, and buy medical devices or pharmaceuticals of the internet.
With respect to that, on the, let's say, buying off Amazon, I mean, it's technically something which it can be called distance sales. So there's technically no importer or distributor taking on the responsibility for that product. And it is up to, number one, the manufacturer of that product to make sure it's compliant. So I've had clients who they'll be selling in the US on Amazon, and they're like, okay, we'll just sell to the EU. But if you know that your product is being used by an EU citizen in the EU, you need to make sure it's CE marked. But obviously in terms of oversight, and enforcement, it's extremely difficult. So it would come down either to the manufacturer or even Amazon to crack down on these other products which are making their way onto the EU market.
Okay, thank you.
Well, thank you for that very good question. Yeah, so
If I may add,
of course, Joanna.
especially for pharmaceuticals, I know now the MDR is suggesting as well temperature control from the moment it leaves the manufacturer till the moment it arrives or it reaches the patient. So I don't think we can guarantee that purchasing through an internet site, for example, you are guaranteeing the temperature control from the moment it leaves to the moment it arrives at you to consume or to be used. There is an element of risk involved, and also the serialization came about clearly to avoid counterfeit products coming into the supply chain. So, and it's a it's a really big task, as you are saying, and very, very costly as well on the part of the industry, because over here, to upload something on the repository is, the fees are phenomenal. So a lot of costs go into these drugs, but these are all contributing to the safety of the patient and to mitigate any risks. So it's up to you.
Do we have...
The FMD directive was brought in specifically for that, to safeguard patients, so as Victor was saying, so today on the single saleable pack, which is the carton, and you see them over there in the Teva stand, you have a unique identifier, and that unique identifier is not just a number, it's linked to that particular batch, and that particular batch has a GTIN number, which is related to that particular product. And then you have a tamper-evident feature. Now, you can acquire something that doesn't have those features, but then it's an element of risk. And then in the pharmacies, we have software that they are supposed to scan the product, and it will trigger that if it is a fake. Because basically we generate data from the line when we manufacture it, send it up to a European hub, and then it is distributed into each and every country and is available to each and every pharmacy. So when they scan, they have all that link over there.
Well, thank you. Thank you, everyone, for answering that question. Thank you for your question. This brings us to the end of the panel. Can I just get a round of applause for Joseph, Victor, Anthony, Kenneth, and Joanna? Thank you so much. Have a good rest of the day.
I extend our sincere gratitude to the panelists for their invaluable insights and extensive expertise in the health sector, which have greatly enriched this conference today. Special praise also to Engineer Cortese for her exceptional guidance of the discussion. This has been a truly fitting conclusion to this conference. For our closing remarks, please allow me to invite the President of the Chamber, Malcolm, for his closing remarks.
Thanks again, Nikki. A day has passed since this morning. Thanks to all for your attendance. I realize everybody has commitments through the day, but I've seen most of you present here. I'm here to give some thanks to people who will not or don't want to thank themselves. So first of all, I'd like to thank our host, Nikki Vella, for keeping us entertained through the day. Usually in this part of the session, over the past 3 years, I used to invite David over here, all blushing. Today I need to invite Alex, so please. Over the last 3 years, thank you for joining. Over the last 3 years, the past 3 conferences, so this is the 4th conference that we are doing as a team. David was the activity secretary for the past 3 years. Now he's vice president. And Alex has succeeded David to the role. And he helped greatly in the delivery of today's event. You can understand that you need a lot of hands on deck when you work as volunteers, but I can safely say that Alex took on as activities secretary many responsibilities. So thanks for that. Thank you for our sponsors, whom you are seeing on the screen, and thanks as well to the person behind the scenes, Marcel. I'm gonna spare you the stage, but thank you so much for assisting us in anything that's related to the administrative portion. And from my end, I just thank you all, guests, colleagues, and friends for being here, and I see you at the next event. Perhaps Alex would like to say something.
There isn't much I can add, but thank you everyone. Thank you for staying till the last bit. I see that most of you went to take a nap. Of course, big thanks to you for attending, because the purpose of this event is mainly to create an environment where all engineers can network and connect to each other. And it's nice to see that many new faces were interested in this event, and we hope that you continue following the upcoming events. Most notably, we don't have a date yet. The Malta Engineering Excellence Award, most probably end of November, early December. Thank you.
So, dear audience, my time to conclude. I thank you first of all for clapping and laughing at my jokes, though there were some silly ones along the way. But mostly thank you for joining us today at this 31st Annual Engineering Conference organized by the Chamber. A quick roll call to thank the sponsors, without whose support we couldn't make this happen. The Ministry for Tourism and Infrastructure and Public Works, Baxter, Schneider Electric, Teva, FMS, Speculo, Tektraco Connect, ST Microelectronics, Aerobindo, Biosynth Engineering, Care Malta, and St. James Hospital. On behalf of the President, the Executive Council of the Chamber of Engineers, the conference's organizing team, Alex, Marcel, and Marcel's dogs, and yours truly, Nicky Vella, I thank you for your participation and wish you all a pleasant week ahead.